LinkedIn.
You are in live.
I will try to fix my background too.
Okay, so let me close everything.
Ignacy, which part of the menu may I do this action?
Have you received one
Yes.
email with the background? Okay,
Yes,
you have to download to your computer,
yes,
and then you have to go to video.
Sonia, quan em diguis,
Down in the left.
Esteu en directe, o sigui que quan vulguis.
No, okay.
Sergio, I'll chat you.
Yes. Okay.
Eduard, you can be.
Okay.
Okay. I think I have it.
I think they are all. I think we are online. Hi, Michael.
Good morning.
Good morning in Florida.
In Florida, yes. Sunny Florida.
Yeah, actually, we have good weather here in Barcelona too. So
yeah, I've been in Barcelona a few times. Beautiful city.
It's a pity. It's a pity. We have not been able to do it presentially this time. I think that we are online, so I'll try to make my welcome. Okay.
Yes,
First
please.
of all, I would like to thank you all, the panelists that you are here. Okay, thank you so much for believing in the project. Okay, that we started. Let's say some years ago, which is the Building Digital Twin Association. Okay, and I'm going to start sharing my screen. Okay, so I'll try to put some order in all the things that I would like to include. Okay, as I don't know if just Ignacio, if you can check if
yes, you have to make exactly right now.
Okay, perfect. So as I was mentioning, it's a pity not being able to do it in Barcelona. Okay, but I hope next year we will be able. But first of all, I would like to thank not only to the panelists, but I think that we have more than 500 registered participants from more than 20 countries, which I think it's actually out of the boundaries of what we were expecting. So I cannot but say thanks to all of you and all the people who are assisting to this first Congress. First of all, I would like also to mention what is the BDTA, what is the Building Digital Twin Association. The BDTA is a non-profit created in Amber, and although the vision and mission, I know it's long, I think that it would be nice to point up to what we are looking with when we were creating this. And as vision is to allow the coordination of multi-criteria efficient decision taking across all IECO stakeholders. Okay, IECO, I remember, is architecture, engineering, construction, owner, and operators across EU building stock. As a mission to develop an open and trustworthy techno-economical ecosystem to advance towards full implementation of building digital twin environments across all the stakeholders, that's really important, all the stakeholders and life cycles of this IECO, smart and connected real estate and infrastructure assets. I know that's tough, but I think it's important. And also pointing that we are considering as stakeholders the occupants. So at the end, when we are talking about building digital twins, at the end, we are all part of this as occupants, as tenants, okay? Because at the end, we are talking about our homes, and that's really important to point out that we are talking about digital twins of our homes with all the things that it implies. So at the end, it's not only professional, but also non-professional stakeholders, development and community of what we are talking about. That's the guiding principles. As I was mentioning, this is related to the homes. So at the end, we are talking about open, but also ethical And actually, one of the talks today would be about trustworthy digital twins, which is really important. Obviously, reliability and also circularity aspects to focusing towards the climate goals, okay, to the green transition that we are all expecting, not only in Europe but across the world. Okay, so if we want to reach what it's really needed and is crucial to reach in the future years, okay, but always keeping in mind that it has to be economically feasible, okay, that it will provide economic value. The origins of the BDTA started with the Sphere project, and actually it's partially this Congress is part of the Sphere project, okay, which is a 48 months European project funded by the European Commission, and the BDTA was born in the cradle of this project as a mechanism to gather and distribute the open knowledge generated by it. Okay, so actually. A typical thing of the European projects is to have create an association after the end of the project. We tried to do it before the midterm of the project, so we could start to make not only all these disseminations and community creation, but also trying to work in the other working groups that and strategic axis that I will mention afterwards. That's the technical objectives of the Sphere project, and all the open knowledge which is being generated by the project will be included into the Building Digital Twin Association. That's the Sphere consortium, and actually that's the BDTA funding members, okay, which are 28 partners from 10 different European countries, but obviously we are looking for new partners. Okay, we are looking for new members of the association, since this is something not only for Europe but for the world. As the strategical axis I was mentioning, at the end we need a community agreed developments to reach the vision and mission that we're talking. We need a community agreed developments in processes, skills and tools if we want to generate this massive implementation of building digital twins across the world. Of course, we need methodology, we need definitions, we need trainings for the new roles which is going to be needed for the taking, okay, for the implementation of all this data curing, of all this traceability across the life cycle of our smart buildings. We need also open technology. We need data governance open tools for creation, for management. As an example, I'm mentioning here the Sphere Platform as a Service, the BDTA Open Ontology network that will be introduced afterwards, and the Open BDTA API and Symbots that will be one of the presentations that we will have today. As part of the BDTA community, obviously this is an event, but we also are creating the working groups, which are already set. And those working groups are meant for first definition and roles, the open technology framework, the vertical digital twin aggregates, and the building lifecycle management simulation, which is going to be part of the second white paper. The first white paper, actually, you have here a QR code, okay, if anyone wants to download it, and the ambition of this working group is to generate this community-based common set of definitions, roles, and the related procedures to reach interoperable building digital twins environments. For as any digital twin environment has two purposes, interrogative and predictive. Okay, and this is an inherent part of what a digital twin should be. As this set of digital twin definitions, based actually on the taxonomy created by Michael Greaves, by the Professor Michael Greaves, that we have the honor of having here after me providing his keynote speaking. Okay, was the white paper that we generated in 2019. Yeah, before the COVID. Okay, so working group number one. Okay, this this part of the white paper, okay, the definitions are already there, okay, and also new roles that is the building digital twin manager, the configuration manager, the simulation manager. This is really important since not only are software tools, not only are standards, we really need new professionals with new capabilities. I imagine 20 or 25 years ago, considering an architect that will be able to work in 3D and will be able to handle databases, and it would be like something that was quite weird. But right now, let's say that BIM coordinators, BIM managers are more and more demanded, okay, from the last 10 years up to now. As new steps in the sphere, and it's also mentioned in the white paper, we have 4 roles, okay, testing the proposed definitions and roles in 4 real pilots across EU. And we are also developing, and this is also in participation with PMI, which by the way, they are also presenting here, providing the first training guidelines, okay, for all those new roles that we are proposing. The working group 2, okay, is the open technology framework. In this, we are trying to use as much as possible open standards from OGC, from Building Smart, from World Wide Web Consortium. Okay, for example, from World Wide Web Consortium, we are using many part of like the SSN ontology or the bot technology, okay, to generate an ontology network that could be also extended using ISO procedures. Okay, but at the end, the ambition is to generate an open technology framework which will allow and improve interoperability across the building digital twins. Okay, that will allow us to create horizontal digital twin aggregation, but also an integration across all the let's say the digital logbox of the buildings that will behave as a digital twin thread. This is an example of what I was mentioning, this ontology network. And based on this, we will be also, or we are developing inside the Sphere project, the open API, which will be upkept by the Building Digital Twin Association after the end of the project. Another part of the interoperability is the vertical aggregation, and that's the part that is focusing the working group 3. Okay, how we can link with other digital twins that are going to be across the hierarchy, okay, from buildings, okay, which are going to be the hinge in between cities and in between manufacturing, in between smart and connected product systems that like might be my HVAC or might be my connected car, electrical vehicle. Okay, so at the end is the ambition is to generate liaisons. Actually, we have the technical director of the Digital Twin Consortium today as well, which is a pleasure. But there are also liaisons that we are starting to work with, okay, and working to talk with people from Gaia X, from Fiverr, okay, to be able, okay, to provide and improve interoperability across this hierarchy of digital twins. And finally, we have the simulation. Okay, the simulation, this building life cycle management. We have to remember that a digital twin is meant for provide solutions for product life cycle management. We have to consider our buildings as products. Okay, and this building life cycle management simulation is going to be it's include obviously inherently inside of the digital twin environments, the building digital twin environments, and we need, okay, to develop the necessary procedures, the tools, and professionals as well towards a cost-effective simulation across building life cycle. Okay, as main technical targets is the creation of the software in the loop, creation of simbots that will allow, okay, a connection, okay, with the BIM world and the sensing world, okay, but also strategies. The strategies of the monitoring it might be the key during the design to reach this software in the loop. I think it's important to mention that the next white paper is going to be just released in a couple of 3 months. Okay, it's going to be focusing on the simulation management. Okay, and in this group. I'll try to end quick. As for today's agenda, we have 2 sessions. Okay, digital twin initiatives that are currently going, and new horizons, new proposals, new projects, new endeavors that are happening is going to be the second session. We have 70 speakers. Okay, I think I'm really proud of the panelists, and I'd like to thank you again. Finally, okay, last but not least, I think it's important to mention that for next year, we will try to do it presentially, both, I don't know if in Antwerp or in Barcelona, but at least we will try to do it presentially, okay, and in collaboration with the European BIM Summit. So thank you so much, and please, Michael, I think it's your turn, so let me stop. I don't know.
You need to stop sharing your screen, I think.
Okay.
Yes, Eduardo, if you stop sharing.
To be honest, I'm trying, okay, but maybe I need to make Michael to run him rights.
No, not mine. Let's see.
Okay. Michael, the floor is yours.
Yes.
Thank you. Screen sharing. And you should be seeing my screen, yes?
Yes.
Perfect. We do.
Good. Hello, when technology works. So good morning from Florida. Good afternoon over in Europe, and I'm really pleased to be here to present and kick off this great conference. And so the topic, my topic is this idea of authoring the digital twin, and I really want to kind of bring you through sort of how I view it, and I'm obviously very pleased that the taxonomy has been picked up by this group, and I think and I'll try to justify why that makes good sense. So I want to basically bring this back to the fact that the conceptual ideal for the digital twin is not a recent thing. It dates back to 2002 when I had created it for Society of Manufacturing Engineering forum in Michigan. And it really didn't even have a name at that time. It was the conceptual ideal for product lifecycle management. But it had been something I'd been working on for a long period of time, is this idea that we were really being able to pull information out of real space and create, in essence, an artifact in virtual space. The gating factor was the technology ability. But if you stop and think about it, we've really had sort of virtual space for as long as there's been humans, but they've been in our mental space. And the problem there is it's not shareable, and our computing capacity to really do complex things is pretty limited. But this was the original perspective of it, and is really sort of continued on. The only difference is I had these sub-virtual spaces underneath the virtual space to call out the fact that we only have one real space, but we have an infinite amount of virtual spaces that we can use in terms of being able to try and experiment to do things that we couldn't do in physical space. In about 2010, when I was at NASA as a consultant, this is the model that got defined, and it's prettier graphics. But the concepts are pretty much the same in terms of the fact that there are really 3 main components to the digital twin model. There is the physical space and the physical artifacts that we've always had, and that still continues to exist. The new addition here, as you saw from the first slide, is this ability of having a virtual space that turns out to be digital because we have the digital computing capability, and the ability of extracting that information from physical space and creating not only the artifacts in virtual space, but a virtual environment. So the issue of it is that the physical space trumps virtual space every day of the week because we have to live in the physical space. And so we need an environment that will represent not only the geometry or the image of what it is that we are dealing with in physical space, but also the ability of having the behavioral aspects be modeled and simulated in virtual space. And so in 2010, this was presented in a couple conferences. The third aspect, and I think this is a critical aspect, is the ability of linking these two spaces. So we take data from the physical space and we populate the virtual space with it, but then we can use that information that we can generate through modeling, simulation, behavioral aspects, and we can use that information in physical space. And why? What's the value here? The value is that information is a replacement for wasted resources. Not for the resources I need to do a task, but for anything over and above that. And so even though we can't replace all wasted resources, even if we can replace a fraction of them, we basically can, in essence, be much more productive and effective. If we make our mistakes over on the virtual side, it has very, very little cost compared to making those same mistakes on the physical side. So this whole idea and why the 21st century is so unique compared to past centuries is in the 20th century and before, we pretty much had to do all our work over in the physical space. So as soon as we came up with an idea, even though we would have a mental model of it, we had to make it physical, either in sketches or blueprints or physical models or whatever, in order to be able to share that information and in fact enable to deal with it in any kind of capacity. The 21st century is unique in that it's the first time that we've been able to move that work over into the virtual area and be able to do real, actual, and pretty substantial work. Yes, that started, in the last half of the 20th century, but it's really flowered and primarily even in the last decade. As I said, the digital twin model goes back to 2002. I was pretty much ahead of the curve there, but now we're starting to see from about 2015 on the ability of the technology to be able to implement it. What's kind of interesting about the building aspect of this is that in some industries, notably nuclear reactors or advanced aircraft or spacecraft or even complex medical devices, the digital twin is the ability of being able to create new kind of products that we couldn't create before in terms of scale and scope. Where the building industry is different is that for millennia, the building industry has been basically doing things at a pretty massive scale, from the pyramids to the Greek temples to the Roman era. And if any of you've gone to the Parthenon, I mean, these are sort of amazing kind of buildings of scale that we don't see in kind of other products. You move into the churches of the Middle Ages. I mean, and look what Notre Dame is, and the ability of being able to recreate Notre Dame because we created digital twins of it is pretty amazing. And then finally, the skyscrapers of today. So clearly we could do scale before. So what's the advantage here? The advantage is going to be the fact that the use of resources is going to be a lot less, and the ability of doing more quality things, I think, is going to be fairly substantial. And so this is sort of the value of the digital twin model, is being able to move work into the virtual era and be able to, in essence, reduce our costs and produce more quality things than we have in the past. The kind of issue for the industry as a whole is there will be adopters of this. And in essence, if you don't move into this area, you will not be competitive. And so the issue here is not that, gee, this is nice to have and I'm going to get some pretty cool models and being able to do some 3D stuff, is the ability of the adopters to reduce costs, time to completion, and have a better focus in the buildings and things that have been done in terms of being able to manage this better are going to be substantially different in terms of resource usage in the digital twin era than not. So the choice is that, you know, do you adopt this and be competitive, or do you not? And in essence, you are going to be at a severe disadvantage, if not go out of business. So I want to sort of talk about the digital twin types, because this is a taxonomy that Eduardo mentioned. And I think the key thing here is the fact that it is important that this framework exists across the entire product lifecycle. And in the past, we have been fairly siloed in terms of the engineering, architecture, and design, you know, existed, and then it was, you know, thrown over the wall to the builders to go build it in either manufacturing or facilities, and then they turned that over to the support people. And in essence, these were very, very siloed kind of situations in the fact that information was not shared very readily. So the types of digital twins that I have is the first one is the prototypical digital twin, which means, as you can see sort of from this image, that it takes shape over time. And so we come up with an idea first, and then we want to go realize that and in essence build it. Now in buildings, there's a uniqueness to buildings, although quite frankly, one of the capabilities of why we can build the scale we can build is a standardization, obviously, in terms of being able to do that. And I guess that the architect Geary doesn't fall into that category, but pretty much other buildings do in terms of being able to have some sort of standardization. You know, these are all the products that we can make. And so the more work we can do here in terms of moving that work virtually is the more time and money that we can save. We then move into what I call the digital twin instance. And this is actually what did we build? And so these are the products, all the products that are made. And our focus here is the fact that we now want to have a digital twin. In the digital twin prototypical view, we can use virtual reality in order to walk through buildings that we have never, that really don't exist. When we get into the digital twin instance, we need to think about, you know, how did we censor this stuff so that we can have the information about how this building was made and how it's performing in order to be able to do a better job in terms of both reducing cost and improving quality for its occupants. The final category, and this sort of came a little bit later in my thinking about it, is a digital twin aggregate. And that is, if I can collect all this information about the things that I've made and be able to then correlate it with outcomes, I can do such things as, for example, predict elevator maintenance, HVAC performance, where the occupants are going to be in a building at a particular time in order to be able to do energy management. And so the more information that I can have across a wider range of facilities is going to be able to help me. Now, when I start to look at different units of analysis in terms of you know, subparts of buildings, you know, cities, I mean, you know, the ability of building that up and being able to have ontologies that are going to drive this is really going to be an interesting aspect. And there's a fair amount of work, in fact, a lot of work that needs to be done in this particular area. This is a slide from an ARUP digital twin brochure or paper they did. And the focus here was the idea that what are we going to look at in terms of driving the digital twin? And sort of the two aspects that I kind of highlight is the technology is a huge driver of this, and there's no question about that. But culture is going to have to change. And again, so the advantage that the building industry has is they have millennia of how we have thought about building structures and even the cities that they're involved with. But the drawback of that is now that's an ingrained culture, and the culture is going to change in terms of how we have to think about going about in terms of architecting, designing, building, and then being able to support these facilities, and how they are going to integrate across a range of not only structures that are like them, but also fitting into the ecosystem of which they're always a part of. And so while we focus a lot on the technology, one of my big concerns and focuses is culture. How do we basically train people to think about it? Because you're going to think differently about these sorts of things. I want to kind of show why this is an enabling in modeling and simulation, and as we bring artificial intelligence into play. And by the way, my issue with artificial intelligence is if you start to have autonomy in facilities without a digital twin, the probability of having a catastrophic event probably goes up exponentially. And so you want digital twins of your facilities, especially if you start to produce intelligence. But if you look at kind of, this is Moore's law that hopefully you've heard about, but this is the idea that every 18 months we double the number of transistors on a chip, and this is a proxy for the fact of how much computing power that we have. And so when I was involved early in the computing industry, you can see we didn't have much in terms of the way of transistors on a chip. But today we passed 54 billion transistors on a chip. And so if this was a regular curve and not a logarithmic curve, you would see the fact that we have reached the inflection point and we are going straight up. So the amount of computing capability that we're going to have to drive technology is going to be phenomenal. And in point of fact, my sort of back of the envelope predictions is by 2030, we're going to go from this 54 billion to 7 trillion, which is a 128 times increase. And by 2040, 885 trillion transistors on a chip, which leads to a 16,000 times increase. So one of my kind of focus points is the fact that we need to be not thinking about what kind of capabilities do we have today, but what are we going to have in the near future in order to be able to think about the sorts of research and focus that we need to have in terms of being able to develop that. So again, when we start to look at culture, there are a lot of implications about it, but we're going to go from physical siloed work to virtual work, which means that this whole thing about each group having their own information and not sharing it has got to basically be broken down. And so we're moving from a functional perspective of work to a product-centric perspective. And so we want to populate and consume the same informational base, irrespective of where we are in the product lifecycle, because quite frankly, that's going to be able to allow us to use this information in order to replace wasted resources and sort of do two things. One is certainly the time and labor that it takes to do it, but also the amount of clock time, which is never recoverable in terms of that. The other aspect is that we have, and I don't think we've sort of appreciated it, the rise of digital natives. And so the workforce that's coming into play only thinks about these things in how they are in terms of digital. They have been born in this area. I mean, one of the things I get is who's going to train them to do these sorts of things. They instinctively know that. A few years back, I had a young granddaughter. She's about 3 years old, and she was a digital native, and she had a magazine, and she's taking the magazine picture and trying to make it bigger. Okay, it's not working for her. She's not happy about that. And so we have digital natives that are coming into play here that I think are sort of critical in understanding that. So it isn't a matter of, should we adopt this? We're going to have to adopt it in order to be able to have our workforce that is coming into play be able to be productive and do the innovative and things that they have been done. On the other hand, they don't have the experience that the older generation has, and so we're going to have to basically integrate the experience that the older generation who are used to, who as Eduardo said, never thought about 3D models or this sort of virtuality, and be able to in essence take the best of both worlds for respect to that. So I just sort of want to kind of finish this and talk about how this is evolving and what is our focus in terms of the idea of the digital twin evolution and where we're going with it. And so if I look at the y-axis as being the information evolution, meaning that it's going to be the more complex and defined information. And so those are my ontologies and taxonomies and integrations. And then moving from the physical world to the virtual world.
Michael,
Yes.
1 minute.
Yes, I'll finish.
Thank you.
And so we have traditional methods that we've had in the past, which were paper-based and blueprint-based. Transitional, where we're moving into the virtual world that has occurred. Conceptual, which I think we're in right now, which is the idea we have of the digital twin, and we're focused on that whole idea. We're going to replication, where we connect the two together and have this focus on this. And then finally, this whole idea of predicting the future with digital twins. And so the ability of being able to take the information from today, in essence, have a crystal ball into the future. And with that, I'm like to thank you for the invitation and turn it back over.
Thanks to you, Michael. Thanks to you. So, Ignacy, I give you to take the lead.
Okay, thank you so much, Michael, for having this story about how it began with NASA, and probably with this information that probably we will be run out of transistors in next decades with these numbers. So thank you so much. And now it's time for Miguel Ángel Sicilia Urban. He got a degree in computer science from the Pontifical University of Salamanca, and he's a PhD from Carlos III University. So he is currently the editor-in-chief of Emerald Data Technologies and Application Journal. So let's go, Miguel Ángel.
Okay, thank you. And thanks to the organizer for having me here. I'm professor of computer science at the University of Alcalá, and one of my research interests is what is nowadays called trustworthy artificial intelligence. So today I will be trying to speak a little bit about how this concept can be translated to the world of building digital twins. Just going directly to the point, this is all about BDTs and people. Here you have the quote of the definition of what a BDT environment is, just directly taken from the Sphere first white paper. And I just highlighted the predictive aspect, because prediction with or without automation, using machine learning or using other traditional simulation or pattern matching techniques, is something like the core of this evolution and of digital twins. And there are two issues to be considered here. The first one is that a BDTE may collect personal information, which of course entails different GDPR relations. In some cases it is explicit. You can see that in some existing ontologies, but in most of the cases it's implicit, because sensor data in general, the data collected by sensors is pseudonymous data, because it can be linked with other data to help de-identify people. But in any case, even if the BDT doesn't collect any personal information, the algorithmic decisions made by this data will, of course, affect some of the users. And this can be a direct effect or impacting the users, or it can be indirect in the sense that the performance of the BDTA may affect people not physically present. So there is one idea promoted by the European Commission, that is what is called trustworthy artificial intelligence. Later in the slide, I can give you all the full references, but there is a document which is called the Guidelines of the European Commission High-Level Expert Group in Artificial Intelligence, And they say, okay, artificial intelligence or analytic systems in general should be, of course, compliant with regulation, ethical and robust. But then they enter into more detail, and here you have this list of 7 elements that this expert group considers that these analytic systems might pursue. And if you take a look at the list, it's very comprehensive, and we can spend one full day speaking about each of these aspects. It's involving human awareness, but also technical. It's involving privacy, transparency, a lot of different things that you can read carefully in the and they are described carefully in this report, in these guidelines. But here I will be focusing only on a couple of the issues in this list, just to emphasize how this might affect the digital twin environment in a building. And first, we have to consider that social acceptance of technologies in general is strongly dependent on how we humans and users and stakeholders think that technology is trustworthy. And if we consider a BDTE as something like a bidirectional data stream, so that sensor data goes into the system and then through actuators, some decision or some actions come to the other side, then there are 2 basic elements of the previous list that are important. The first one is robustness, and the second is privacy. Robustness in the sense that the data collected could have been forged or tampered with, or may not be as trustworthy as we may think, and this will entail decisions that may harm people, property, or in general the environment. And that's something that it's important and is a baseline thing. The second is, of course, privacy, because even with temperature sensing related with other elements, you can get personal data, and there are many demonstrations out there of this kind of linking patterns for the identifying people. And the rest of the elements in the list basically depends on these 2. This is why I'm today just pointing out to these 2 particular ones. Just a quick overview of how this might impact digital twins. The first one is about security. And of course, we know that security is in information systems and in IT is about vulnerabilities. And this is known to be higher at the edges. And digital twin at the end is a system, it's an IoT system. So all these things may, the things that we know about cybersecurity that affect IoT are also very important in digital twins. And here I wanted to point to the field, the study field of adversarial machine learning, which is basically people that is trying to develop techniques for stealing information, poisoning machine learning models, or even evading the correct functioning of these models. And these are very, very popular, for example, in image processing. If you look for that in the web, you will see that there are a lot of techniques for evading facial recognition and all this kind of stuff. And this is the business of fooling predictive models, and it's a field of study in itself. And the problem is that in a building, this may cause incorrect actuation of the let's say decisions taken by a digital twin environment. And also you can check that there are many techniques that are specific to IoT, like jamming or respect to poisoning. So this is well developed nowadays. Traditional mitigation for this kind of vulnerabilities are, of course, related to the hardware, anti-spoofing measures or failover design. These are traditional for the field of cybersecurity. But there are other solutions that might be considered in the design, like, for example, blockchain meshes and active anomaly detection. But for example, if you want to have anomaly detection at the edge, this doesn't come without a cost, because that's in a sense computationally expensive, and you have to carefully think if this should be or the extent to which this could be incorporated in the design of your BDT environment. So just to give you a quick example of that, and that's a reference that is also in the slides, and you can check it later because we can share the slides with all of you. Here you have an example of a cyber-physical system that was designed, and here on the left you have the typical setting in which you have this cloud-based part in which let's say the digital counterpart of the physical building will be maintained, and then you of course have sensors and actuators. And here a very interesting example in this paper is that if you have, for example, a system of flowing water through pipelines, if some malicious agent wants to spoof or want to fool one of these sensors, if you have a simulated environment in the digital twins, this becomes harder for the attacker. Why? Just because you can check in the real-time simulation, by any means, machine learning or not, that, for example, if they are compromising only one sensor, you can correlate with the other two sensors and then quickly spot and find out that somebody is trying to fool the system. So simulation is also a complete simulation is also a tool for making the system more robust to this kind of attacks. Okay, that's one side of the thing. And the second one, and with this I'm quickly finishing, just to keep on time, is related to privacy. And here, probably the most important technology and innovation development is a set of techniques and methods that is collectively nowadays called privacy-preserving machine learning. Again, that's machine learning, but it could be also analytics in general if it is not strictly neural networks or something like that. It could be other analytic techniques. And for example, federated learning is what Google is using, so that is something like things are training, for example, in your mobile phones, and then the models are sent to the cloud, so that the cloud provider, in our case, the digital counterpart, will never see the data from the users. And that's a incredible innovation, and it's being applied in many places. There are other ways of doing that, for example, split learning, so that the models can be split into parts, preserving privacy to a certain extent. And there are a lot of combinations here. Here you have an example from another paper that you can check out later, in which you apply different of these techniques at different points in section. So again, this is something that we should consider in the design of future building digital twins. And okay, that's, I think I'm something like 10 seconds late. So my outlook and conclusion is that we need to incorporate all these things into the design of these systems to make them baseline compatible with the European Commission idea of trustworthy analytics or trustworthy intelligence systems. And that's all. I hope that I stick to the time. Thank you very much.
Thank you so much, Miguel Ángel, Cecilia, because this is connecting with what Michael was showing us about this culture of trust.
Yeah,
so
sure.
This is something that we will have to analyze very, very well. Okay, now it's time for Andrew Lovern. He is from BDTA Ireland, and he's a sustainability consultant. He's an experienced product and project manager, and he has been dealing with digital twin technology. So it's your time, Andrew.
Thank you very much. Can you see that screen, Ignacio?
Yes, perfect.
Great. Yes, thank you again, and good afternoon, good morning, depending on where you are. My name is Andrew from BDTA Ireland, and I want to do a very quick presentation today with perhaps a slightly different focus to some of the other presentations, which will be focused on the technical and the twin. And what I want to talk about today is digital twins' response to COVID-19, and really to think and talk about the human beings involved with digital twins. So why is everybody not as enthusiastic about twins as we are, everyone who's on this call, obviously? Why are the obvious benefits of digital twins not being taken on by everybody? These are not digital twins that you can see. These are my own analog digital twins, Sam on the left, Ben on the right. And you can see my oldest child in the middle is clearly not very enthusiastic about the twins he finds himself with in the back of the car. Let's consider him to be our digital twin manager. The problem that or the challenge that we face is to try and solve his problem. And to solve his problem, we need to understand what's making him unhappy. Now, trying to understand the mind of a 4-year-old is not feasible and not what we're here to do today. But what we're here to do today is think about the problems that COVID-19 in particular has caused for people in the built environment, and what we might do to help them and to show them the answers via the implementation of the digital twin methodology and the approach. So how do we do that? In my opinion, we need to solve the problems for the individuals, not to create the solutions and then go searching for implementers or people who match that criteria. And we need to solve their problems. And what are the problems for stakeholders in a built environment? And specifically, I think today for me, the problems that have been caused or exacerbated by COVID-19. I've selected just a couple. There are obviously many, but I think one of the first issues and problems that we have to solve is the uncertainty, and the uncertainty that COVID-19 has brought. It's probably the biggest change to most of our lives, that in living memory for almost all of us. It's changed everything. It's changed how we work. It's certainly changed how we build, and it's made things very, very uncertain. And uncertainty in the built environment and the construction environment is a real enemy to the construction and the built environment. The built environment hates uncertainty, not knowing what we can do, not knowing when we can do it, and not knowing how long it's going to take. All of that has obviously a cost implication. And somebody's on speaker. The second problem, which clearly has been exacerbated by COVID-19, is safety. So human safety. So COVID is a public health emergency, and the physical safety of all stakeholders in the built environment have been affected. Access is a clear problem. So many of us haven't been able to access our workspace. Many of us certainly haven't been able to access buildings that are within our remit, be that professionally or as a resident. Residents themselves haven't been able to leave their property, which causes an access problem for those who want to come in, and data retrieval. So there are still many buildings that hold their data within the building itself. Maybe that's consumption data. Maybe it's data directly from the humans, the residents in that building. These are the problems that have been amplified by COVID. And I want to use this as an example. I want to use social distancing as an example. Social distancing, which is a phrase probably none of us really heard of, or certainly wouldn't have understood maybe 15, 16 months ago. And now it's central to every single thing we do the second that we leave our front door of our house or our apartment. And why is this important for what I want to talk about today? I think it's the normalization of what is such an extraordinarily different new way of dealing with people, dealing with things. Every single social interaction we have now, whether it's the shop or the street, how we walk down a path, how we walk down a road, how we walk through a park has changed. And this is interesting for us when we think about the uptake of digital twins, because it tells us how adaptable we are as humans into fundamental changes in our society and in our needs. We are actually willing to do some extraordinary things to solve the problem. Now, what's the problem here? The problem is we want to go for a walk or we want to go out, but we're willing to do absolutely extraordinary things, as you can see here, to solve a problem. Now, these guys' problem, look at the lengths that these guys are willing to go to have a glass of wine and then sit out on a pavement. Extraordinary lengths. And there's an extraordinary willingness to change behaviors to resolve a problem. Now, what is our response as the Building Digital Twin Association, as a digital twin kind of proponents, and what's the digital initiative? For me, the Building Digital Twin allows stakeholders to practice a professional distancing. So the ability to digitally interact with a building is fundamental to the idea of a digital twin. And those 4 issues that we looked at in the earlier slide. So uncertainty, the enemy of the construction industry and the built environment. How is that reduced? It's reduced, as Michael said in the keynote speak, it's reduced by allowing us to make our mistakes in the virtual space. So now we can carry out some design, we can take information, and we can make decisions in the virtual space. We can professionally distance ourselves from the building and make some decisions and carry out some actions. Safety, clearly, in relation to COVID, there is no risk in the virtual space of catching or transmitting COVID-19 or any future, similar kind of infection or pandemic. Access is either no longer required or is significantly reduced. We no longer have to send somebody to take information or to view a building or to take data or to interact with the residency. We talked about the guiding principles of ethics and trust, as Miguel just talked about. Digital twins allow us to access that virtual space, which means we don't have to access the real space, and data retrieval. So information that's locked in a building during COVID, that information is still in that building. If it's not viewable to us, to the outside world, it's of no use. And there's also a role here for thinking about how people have changed their work. There are many buildings where building information is kept in a BMS or a terminal in an office. Those offices have been closed for 6-9 of the last 12 months. And so that's how professional distancing allows us to go around some of the problems that COVID has shown. So to conclude, and I want to try and give Ignacio back some minutes, the digital twin offers us increased professional distancing opportunities, and professional distancing itself will allow stakeholders to navigate their way out of COVID and the uncertainty, and to prepare for future interruptions. I believe that when the next COVID comes along, or the next threat of COVID, the reactions are going to be very different, and they're probably going to be more extreme, and they're probably going to be very much sharper. And it's beholden on all of us to prepare for that. And having a digital twin and some professional distance will allow us to prepare for that, to be ready to be to improve and increase the size of this virtual space. So if we can, as an association and as a group of experts, if we can identify and ease the problems, then we will have smiles and we will have members. If you look at the picture on the right, so this is the same grumpy boy on the same day. We've identified his problem. It was very simple. He wanted an ice cream. We provided that, and this is the end result. So that's professional distancing and BDTA's response to COVID-19. Thank you very much.
Thank you so much, Andrew. You have been talking about resilience, and well, in fact, we will need members, and we wanted to create a very big and huge building digital twin association. So this is our focus. So thank you so much. Now it's time for Pablo Vicente Legazpi. He's a mining engineer. He has been specializing in metals, and he has been working in usability, petrochemical, construction, analysis software. So a very nice background. So let's see, Pablo, which is your approach.
Do you see my screen?
Now it's being uploaded. Yes.
Yeah. Let me check.
It appears EcoSim Pro.
No. It's I click in the wrong place. Sorry.
Oh, they're not mine. Check.
Should be this one.
Check another.
It's okay now?
Right. Perfect. Symbols and BDTA.
Okay.
Yes.
Okay, I had to speak about the one of the work groups of the Building Digital Twin Association. Edward has mentioned in it that we have like different working areas. One of these areas is the group of simulation group, the group with these objectives I mentioned here. The mission is to develop procedures, tools, and professionals towards this building's life cycle simulation scenario. And we see that like 3 pillars. The first one would be methodologies. This includes training, qualifications, professional certifications, monitoring, all those aspects around the simulation in a general way. The second pillar would be the software in the loop concept, which means that we want to put together the real-time simulation, the monitoring, and relationships with SCADA, BMS, and sensors in the building. And the third pillar would be SimBots, which is a new concept we want to develop, including the standardization of connectors for simulation. SimBot could be like the simulation of an equipment. Well, all this effort of this simulation work group would be oriented to software developers, to engineering firms, and equipment manufacturers, but it is open to any stakeholder in this sector. So feel free to connect us if you are interested in this field. Well, the SimBot development, this is one of example of what we want to get. It could be, this is you see in the screen, a home ventilation machine, which is an equipment we can use for ventilation. And this on the left is the simulation model of this equipment. So we can see the fans, these symbols are the fans of the real system, the physical system. We have the recuperator, we have filters. So we can reproduce totally the functionality of this home ventilation machine. As soon as we finish this model, we can pack all together and we can generate a component, which is this one. And this could be the SimBot concept. It's an equipment. It's a collection of functionality associated to one manufacturer's equipment. Okay. So the idea is very simple: is to pack all this simulation into one single component, just to be able to very quickly to generate simulation models of a building. Okay. Why SimBots? Because they are important to make simulation economic and affordable. Otherwise, it wouldn't be, we wouldn't have enough time to collect all the information and to put it together in a building. SimBot allows us to test before buying or installing something. We can test how equipment networks can be integrated, and even we can do a virtual commissioning of parts of the building. Okay, so that is a very, very useful resource. We can easily include control parameters into simulation, so we can test control parameters as well. We improve the visibility and detection of faults. We improve the knowledge about our own house, and we improve the calculation of comfort KPIs. Okay, so all this together makes SimBots, we think, a good objectives of this working group. And why standard connectors? Well, SimBots can be reproduced in a standard way of FMI standard. But these FMI components must be connected between them. So those connectors, the ports, must be standardized. We need these ports to be standard to be able to connect components from different simulation softwares in such a way that all of them should be using the same ports. For example, fluids. A fluid can be a very simplified mix, or we can have the air with humidity and the composition of the air. So to have calculation with CO2. So to define all these small details is very important in order to be connecting SimBots from different origins, different simulation software. And this is to end. We are writing right now in Sphere the white paper 2, which is oriented to simulation. You can see here the authors we have at the moment and the contents of the document. The idea is to get between 50 or 100 pages. And this could be like a document to set up the directions of where we want to go in the future. So again, feel free to contact the BDTA if you are interested, because we welcome any any collaboration. And nothing else, nothing else. Thank you very much.
Thank you so much, Pablo, for explaining us about this new white paper. Let's remember to all people that is listening to us, you have the first white paper also in the BDTA website. So let's invite now to Wouter Bostrom. He from TNO, and he has been working a lot in this kind of twinning dwellings, and also very related about issues as air ventilation, air renovation, and energy. So Wouter, yes, we see your presentation, and the stage is yours.
Okay. First of all, thank you for giving me the opportunity to tell a little bit about our work. Short, 1 second. There's a short slide about myself, Wouter Bostrom, working at TNO. It's an independent research organization of about 3,500 people. We just finalized a paper about predictive and digital twins in the built environments. Can be downloaded for free. It's both in Dutch and English. Also working on the AEI on Annex 5, and made some publications for that. And I think the AEI was in the news because they have made a report about net zero energy in 2050. I think quite interesting. So we have, I think, quite a few challenging also for the energy transition, not only COVID, it's like indoor air quality and health, but also for energy. And we now have buildings, we provide tons of data, but do they also give necessary information? And what can BIM and predictive twins mean for that? And this is an example of a data set. It's an office building with 3,000 employees. 600 room temperatures, and what to choose. And here you see the temperature, and this is the time, it's 24 hours. And what we see, this is the parking lot, but the temperature range from 20 up to 24 degrees. And do the people have comfort? And is this also the optimal setting out of perspective for energy? And the main question is, so how can the digital solutions as digital twins really could make a difference for challenges like the energy transitions and indoor air quality? And this is an example. To the left, you see an office building where we have make a living lab. It's myself sitting there with different sensor positions. We have the information for the building management system, and we have also energy data, and with a model to the right, we have different aspects, and we calibrate the model, and we can get data and also give control input. And we have introduced the term predictive twins. So not only predicting certain performance in the future, but also influencing it. To the right, you see the Sphere project, what I've mentioned already. Here we have an energy performance contract for the heat pumps, for the energy and the indoor air quality. This is the BIM data. This is an inspection we did, and now we also have live data, which we can analyze, making use of digital twin. And given this use case, how can we use the BIM information to structure and analyze the data and to check the current performance, especially for an energy performance contract is important, but also detect events and optimize. But what's also very important is to make it operational in both workflows, in commissioning and operation. I will tell a little bit about this later, and how to use it to improve indoor air quality and reduce energy and event detection. Why use BIM? Why not use AI? I think artificial intelligence is a wonderful tool. If you have high quality data and you have enough data, this is perfect. But if you look to the buildings, you see we have lots of data, but important physical parameters are not measured. And this is, for instance, an air handling unit. And in some of the cases we have analyzed, we have the pressure drop over the filter, but we don't have the flow in cubic centimeter actual flow. So we have to have a model to calculate that. And if you use many parameters in a data-driven model and there is poor data quality, and as an example, you have a perfect fit with the training data, but there's a null point and you have overfitting and it doesn't fit in your model. And what is the advantage of using BIM? The physical relations you already know, you don't have to estimate. But also if you have logic boundaries, which are physically determined on parameters, and you can prevent nonsense parameter values. For instance, you have if you get a negative resistance or you get a negative building mass, you know it's not, it doesn't make sense. But most important, you can work with less informative data to fit your model. And this is an example, this is some challenges we are facing when we use BIM data. If an architect makes a model, it's not automatically made for a simulation model. You have to make choices to choose how many zones you can do. Sometimes you have to combine inconsistencies in space boundaries. But also what took us quite a lot of time, if you look at different standards like IFC, GBXML, they don't automatically contain all different necessary data. For instance, installation data is a little bit different. And this is an example of how we develop a model, we called it Siren, where we use both BIM data and dynamic data. So we use, in this case, we have the BIM information, for instance, in a Revit file, we convert it to an IFC GBXML, and then we so a building energy model, information model, and we automatically can transfer that to a building model. And for the user behavior, we use AI, and we call it also the Sirens and Hybrid Goddess. This is a hybrid model, and we use federated learning for privacy. And so we can calibrate it with dynamic measuring data. And so both for the model structure and also for the data, we use Haystack for tagging. To zoom in, how we use this building information, we use this GBXML for the geometric data. We use IDF, that's an energy plus data format for the installation, because we had a lot of trouble either in GBXML, also in IFC, to give really good interrelation between the installation. And then we make both a ventilation model and a heat transfer model, which are solved both simultaneously. And to give a little bit, it's only a minute, an idea of how it works. You select a certain project, and then also you have the ability to select the GBXML file, but it can also be IFC. We use an open source viewer where we can check the data for the different fields and so on. If it's and this is an example of GBXML, but it can also be done with IFC. And then it's automatically transferred to a building model. And we can choose a certain period and certain parameters and do a simulation. And next step we are working for, we try to implement in the coming months, is that we also use this prediction for as a input for model predictive control for balancing on district level. Okay, I want to come to the next slide. So, so the last slide, and really important point, we've seen projects where they invested €1 billion in fancy monitoring structures, but also in diagnostic. But because they didn't invest in the process, it was actually worthless, and it's all the investment didn't give much value. So it's really important to organize both your operational workflow and also commissioning, and to train the staff to get the real data, and also train the maintenance information, and most important, also give feedback to your 7D BIM, because otherwise, you cannot get value of it. So it's not only the building digital twin, but it is also the process and organization and your BIM management during the process, which is create value. If it's crucial to create value. Okay, thank you. This was my presentation.
So much, Wouter, and you cannot imagine how I love this kind of presentations being from BIM Academy, and how to see how BIM is connected to digital twin. This is something that from the Netherlands has been presented by Wouter, and now we go to Israel to see Rafael Sachs' work. And he's professor of civil engineering at the Technion, the Israel Institute of Technology. And his research interests focus the synergy of building information modeling and link construction, and these two areas related to civil engineering, architecture, and construction. So, Rafael, if you can share your, yes, that's perfect.
All right. I hope you can all hear me okay and see the screen well. Thank you very much, Wouter, and the previous speakers for very interesting talks, and to Ignacio and to Eduardo for the invitation to speak today. I will just share with you very quickly some of our work on BIM-enabled lean production control systems, and this really has to do with digital twin construction. Some of it is associated with the work we are doing in the EU project called BIM to Twin. So fundamentally, when we talk about digital twins for construction, like for anything else, we have the real site on the left, and perhaps some conceptual digital representation of that construction site on the right. But we're not talking only about the physical product, we're also talking about the process of construction. And so we have the fundamental links of monitoring what's going on and then operating the site from the digital twin. Now, the monitoring part of it is done with quite a wide range of technologies, some of which we're implementing in the project. But many are the topic of startup companies who are already active in the industry. The challenge today is that they each work individually and separately in a siloed form. So what we really have to do is not just acquire all of these monitored data feeds, but we also have to interpret them and merge them to create meaningful information rather than just the data. And that is quite a challenge, to take object geometry, to take sensors of temperature, humidity, and so on, laser scans, photogrammetry, and all the rest, and convert them into meaningful object geometry, labor flows, material flows, equipment parts, and so on, so that we're able to interpret what actually was done. But if we're able to overcome this interpretation phase, we can establish what we call a project status model, the model of the as-built. And again, we see that some of these technologies exist, sensors embedded in the concrete to determine temperature, which can enable us to forecast the time we can strip the forms, reporting of activities done and not done using 3D cameras, laser scanning, and simple applications where workers report what they have done. Here are just some very quick examples of these technologies that exist and are being used. This one is from a company called OpenSpace AI, but there are others. There's one, for example, called BuildDots, and the way they work is 360-degree photography and then photogrammetry to compare with the BIM model. You can see it here, for example, from BuildDots, the position of the camera taken, the view of the wall, and then comparison between the BIM model on the right, which represents the design intent, and on the left, what actually is there now, with a layout then saying, oh, but clearly the wall should already have been closed by this point in time, and yet it's not, which is then a meaningful conclusion about the situation on the site. There are others like this one, where people monitor tower cranes and they're able to learn things about the building based on the camera, on the monitoring of the hook on the crane. And in the reverse direction too, we're able now to take, and we have tools for laser display, for example, as you see here on the floor, of the building model directly onto the work surface, which creates this two-way communication of information from the BIM back onto the construction site. And the underlying theme that I want to emphasize here is this lean production control. And one of the central tenets within Lean is this idea of doing plan, do, check, and act. This is something called the Deming cycle, and it's really central to a lot of the way that we control production in live systems using Lean construction principles. And what I want to do for you is show you how we map this iterative plan, do, check, act cycle as a management tool onto our digital twins and how we use the digital twin to implement that. So if I take this plan, do, check, act and translate it into equivalent terms for construction, I could say that the planning is actually modeling of a building digitally using BIM to establish design intent and using tools for construction planning. And then building, which is fabrication off-site and construction on-site, monitoring and interpreting that data through all those monitoring tools I showed you before, and then evaluating and improving, which then feeds back into another cycle of modeling, because the assumption is that we only build what we model first. Now, what I'm showing you here is the basic architecture of the BIM to twin system, and it emphasizes everything I've said so far. So we have here on the right hand the physical twin. We build it through controlling the construction. We monitor it down here, and then we get the raw monitored data. We interpret it. We create the project status model, and then we compare the project status information with the project's intent information and knowledge. And having done that, we then predict performance, evaluate feedback for new design, create new design, replan the process, and feed that back to the building. So you can see here that this is, in fact, an embodiment of our plan, do, check, act cycle. If I lay it out, then we have here the planning, as we design the product and we plan the process, the building, where we control the construction day by day, we monitor it. We then, in these three, interpret, evaluate, and predict, meaning we then act, and then feed back into the design, product, and planning process cycle. And that can be, in terms of time, it can be monthly, but nowadays it can be weekly, daily, or even hourly feedback and adaptations. So what we're aiming for, both in the project and in industry, and certainly in academic research, is rather than saying digital twins for construction, we believe that this gives birth to a really new paradigm, which we might call digital twin construction, because our ability to have short cycle times of monitoring, of plan, do, check, act, means that we can do things with far greater agility than we're able to in current methods. And that leads us to many, many possibilities also of business opportunities. Already today, we see systems like this where people can run control rooms for construction projects, production control rooms, not design control rooms. And this is an example from a data center built in Ireland. But you see here not only schedules, models, and details, but when the team meet in the space, it's all of the subcontractors, all of the implementers meeting to decide what to be done. And some of those decisions, once they become automated through AI or through other tools, we may then begin to see an opportunity for a platform business to run multiple projects from control rooms in this way. And so we're talking about digital twins with product and process that function as systems within systems, but primarily digital twin construction, what's new is that it is entirely an information process. And so it has challenges, of course, and it has information and process challenges. And I should simply sign off and recognize the BIM to Twin project as well, and invite you all to look for more information about the project on its website. Thank you very much.
Very interesting, Rafael. I think this process of BIM to digital to Lean, and will open a lot of new doors to new research and new processes. And this is something that will make a little bridge to what Peter Powells will explain us. Peter Powells works as an associate professor at the Eindhoven University of Technology in the Department of the Built Environment. And he has been previously in the Department of Architecture and Urban Planning at Ghent University. So he's fully inside the construction sector. So Peter, it's your time.
Okay, thank you very much. Share screen here. Okay, so thank you very much. My name is Peter. I will give a short presentation here about link building data in digital twins. And I will do this. So who am I? I was already introduced here. So I'm doing this with a background from Ghent University, but also the WDC and Building Smart. I now work in Eindhoven University of Technology, and I would also like to share that I'm going to present some of the projects that we're doing inside Eindhoven at the EASY Institute. So that's the Eindhoven AI Systems Institute, which has a digital twin lab here, which we try to do experiments. So most of my slides will be a bit more technical, I guess. So where do I come from? My background would be in building data, and also then more building data, as you have has already been said. That's already been said by the previous speakers that we have a background in building information modeling, and we are now looking into link building data and digital twinning in general. So we would like to handle building data. It's not only about the data itself, it's also about simulation and processes. But I would like to focus here on the data part at least. So, and in the screen you see one of our buildings that we are working with on campus, which is the Gemini building. Okay, so what do we have in the AEC sector? We have building information modeling for a long time. So we have been going through concept design, engineering, construction phase, and we try to handle our data over and over and over again. This is a bit of a background, and we are actually pretty good at it. So nowadays we are handling digital information on construction site and design and engineering processes quite effectively, meaning that we are using, as already said by the previous speakers, we are using BIM models on site, we're using 4D, 5D models, and we are now moving to, or already checking with point clouds to track progress, for example, and to improve our construction processes. So we are doing already quite a lot with the building information modeling and with data itself about buildings. And this is traditionally done using aspect models which are combined in a coordination model, and then we continue our work. There's also phases beyond the central AEC phase. So we also have these other phases, which is the operational phase and the phase before the actual existing phase, which if you go far back in time, you get into heritage and so on. If you go forward, you go into facility management and operation, and which we would like to do at a later stage, renovation processes. So also there you have digital twinning. It's a little bit different, but still also many aspects are similar. Namely, we still have building data that is being used. And here you can see a couple of images of the Atlas building, also on our campus, in which we try to digitize the existing building, starting from a BIM model, but trying to achieve a number of processes, a number of use cases that help us forward. For example, on the left, you can see a map that is used to navigate through the building. That is generated from the 3D BIM model as automatically as possible. And we're also trying to make it, trying to do the predictive digital twinning where we track the sensor data and try to predict the future operational performance of the building, like temperature, heating, and presence of people, for example. When we go through these individual cases, there's a couple of things that we notice, namely that you need everything that's here on the top of the slide. Well, you need in particular the modeling guidelines and agreements, because depending on how the model is built at the construction phase, you get a different model inside your operational phase, meaning that in some cases we have these space boundaries defined, some cases we don't have them, sometimes we have these as explicit walls, sometimes they are generic models, and it's really difficult to basically work with any of that data if it's all defined differently. So we need those guidelines in our data. Yet we are already happy that we have some of the data here. Something that we have been looking at in the past over the last few years is this BIM level 3 or BIM level 2. You're probably all familiar with this. So we would like to achieve a BIM level 3. That was a few years ago, in which case we have integrated interoperable data, and you have here the web services that are all supplying us with data. Not sure whether we ever will reach this phase, but we would like to have this environment around where information is available on data hubs that are on the cloud. As far as I can say, I think that resembles our digital twin ambitions. You can see this also in our standardization efforts, for example, in the BDTIC, but also building smart. There's a move towards to work towards more generic, scalable, and broadly used technologies, such as APIs, JSON, also APIs, and then linked data, XML, and so forth, which I think is a major improvement because information becomes available in another format and in other media. If you go into that direction, our data also becomes more modular, and it's also more difficult to manage. So you get these isolated, well, not isolated, you get these islands of information that gets available from your different actors and that are supposedly interconnected using web technology. So you have this contractor A, contractor B, and they are basically talking to each other not by sending a file, but by accessing their query interface. And this allows you to automate certain handovers more than what we could using file handovers. So this is something that seems to be ongoing and which is a good basis also for this link building data initiative. So we get this we're ending up with this web of linked data where we have granular schemas, granular ontologies, in which data is connected more on the fly, and you get specialized data sets with query access and also inference engines for compliance checking, for example. So this is a very different planet to what we are used to. And here you can see an example of one of the commercial stores, the graph database, which basically allows you to explore the building on a database level. So this is no real user interface, but at least you can see that you can browse to your data as you go from wall to story to space interfaces between rooms and windows and their properties. If I keep clicking here you can see the properties. So all is good and well, but there are also lots of other sorts of data available. This is the more difficult data. For example, we can see here 3D data, 3D geometric data, geospatial data with multiple coordinate reference systems, sensor data, 2D data, and complicated meshes. So these are typical data that are less handy in a linked data graph, which is also shown in the previous two presentations at least. So we need to have those on board as well. And then for those data, we have a tendency to work towards system integration. That's what we see. And this is where we get closer to a digital twin system. In the sense that we can, for a physical building, we can collect all the sensor data coming from a SCADA system in a time series database, such as InfluxDB. We have the graph database for the semantics and the knowledge. Our 3D geometry or 2D or whichever geometry goes into a key value store because it's mostly binary and file based, and this becomes accessible for end user environments. And what is key there is that we maintain good agreements on the identification system, which you can see here. This identifier is known across these different databases, which allows us to connect the data. I can say more about all of this, but I think this will also be part of the panel discussion. But I would also like to share that we do this not only for smart buildings or sensors and so forth, and for geometry, but also for allowing, for example, indoor navigation. This is one study that has been done in our university by this person, Bob Hendricks, and colleagues, in which we try to let a robot navigate through a building in a more autonomous manner. There are algorithms available for this, such as the SLAM algorithm, But we would like to see if we could use a BIM model to start from, so that we can at least go faster in making this robot navigate the site. This would be useful also for construction site, obviously for automating tasks. And what this robot does, it basically scans its environment using a 2D laser scanner. And based on the feature detection that it has, it tries to match those features with with the points that it has collected in the data store, so in the backend. It recognizes columns and walls by matching the geometry of the 2D laser scan with the 2D lines, polylines that are coming through IFC and IFC JSON and I don't know what, but that end up in the digital twin system. This robot goes on for a while, but that is actually a good environment or case that we should be looking at, because it basically works on the same system that also stores the sensor data for the HVAC system for the facility managers, and that I think is a nice result. I will stop here because I think it's at the end of the time. Thank you very much.
Thank you so much, Peter. We are on time, so we have right now 15 minutes of debate as a round table. You know that this first Congress, it has been conceptualized as a Congress that it will be very, very executive, in the sense that we have presentations of 10 minutes. And we will have this round table this time to make several approaches. So I do not know if some of you have some questions for some of your colleagues. So you can open your mics and you can ask whenever you need. I would like to ask you something that it was being written in the chat by Dennis O'Keefe from NHS Ireland, that he was talking about the importance of digital twin in hospitals. So any of you who has some experience in creating some system of a digital twin inside one hospital, one clinic, some health environment? Don't feel shy.
Well, I have some experience with software called the Rofus and specifications about hospitals. And these are construction with a very intensive, a lot of installations together, some of them very critical. So thinking about the possibilities of simulation in those environments are huge, okay? And they have more intensive money per square meter, so it could be very well justified. In fact, in Sphere, we had at the middle of last year a model for a hospital in Madrid. We didn't have still the demo pilots, so we were testing for the hospital Ramón y Cajal a ventilation system. And it was very interesting because there were some waiting rooms for many people. And the intention of the work was to do a waiting room for this COVID situation with an extremely perfect, concentration of air and CO2 in order to dilute as much as possible the viruses in the waiting room. So the possibilities are huge. It is the message.
Mm-hmm.
Peter, I saw that you were about to say something as well.
Yes, and it's also Walter. Yeah, in general, I think the hospital is not so well. It is different from any other building, but it uses the same methodology. The main difference is your critical systems primarily, I think, and nothing can fail. But there are more buildings in which nothing can fail in any case. But I would in any case go ahead also for the systems part.
Yeah, and I want to introduce a second question. but it's about digital twin and digital twinning, no? In the sense that how we can give constant information to the digital twin. No? And there has been some experiences about this, and we are generating teras of information. How do you think that we have to deal with this huge amount of information? Sometimes that can be unuseful because you are taking the temperature of one room twice per minute during 24 hours, no, per day, and probably there is nobody in that room during 1 month. So how do you envision the future of this amount of data and this relationship with IoT and Internet of Things and all the sensors? This is an open question, so
go there.
Yeah.
Go there.
Yeah. So we also face the problem. So we have like districts with like 100,000 dwellings where we have energy data from, but also in if you have an office building, big office building, you have a lot of sensors. And you have always has to have a good strategy. So one of the things is that you don't load all the data directly. That you choose a certain period. And for instance, we use the last month or the last week. And then also, we do like how do you call optimize the data also for calibration. So. What is the less frequency you can use, but also which variable are relevant, and so the strategy of using the data is a lot of effort because otherwise I recognize that you get huge overflows of data and your system cannot work with it. So thinking about that and also limiting it, and sometimes you need you only need like a week of data. And not all the points, as for instance, an office building. If you have working periods which may be most relevant, and for other periods you can use maybe less frequency. Yeah. So the strategy for the calibration is most important.
Andrew, you wanted to say something?
Yeah, I could just quickly. I think one of the most important things when we think about the amount of data, I think it was Raphael's presentation. And probably the only one where we described the physical twin. So we're talking about the digital twin and the digital twin, but the physical twin, the building. So there's all this data available, and it's the physical twin that drives which bit of that data is important. So where in the physical twin, like Walter just said, which of these apartments do we want to focus on, or is it the car park, is it the place? So I think by bearing in mind the physical twin, we can improve the information we have on the digital twin.
Yeah. And this is also another open question for all of you. Do you think that mainly digital twin will be related to energy problems or energy issues? Rafael, what do you think about that?
No, I don't, certainly. I think that there are so many areas of our life that are going to be aided by managing through the digital twins. I mean, it's enough to think about our cars, our trains, our airports, our airplanes, many of which already are operated by systems that are similar to what we have in mind as digital twins. But we mentioned hospitals a moment ago, and you question what kind of data. I think that we will begin to see that the real value comes in integration of data sources from different fields. So for example, we have information about the building, the hospital. We have information about the HVAC and other systems, but we also have information from, let's call them digital twins of patients and of their medical records and their recovery. Can we look for correlations? And people already do this, look for correlations between who recovers and they have a window in the room looking out on a garden and who doesn't. And so many other things that we could be looking for in the same way that people are looking for drug discovery by searching thousands and thousands of combinations of molecules. You could be doing the same, looking for correlations between the physical environment and actual outcomes for people. And when it comes to building construction, it's clearly not only about the construction project. We deal with construction industries which are multi-projects. So an individual contractor works on one project manager, and we tend to focus on that as our digital twin. But the subcontractors in that site are working on many projects in parallel. And the suppliers of concrete and wood and all sorts of other things, they're supplying many sites. And that links into the traffic in the city and so on. So that we're really talking about, in the end, systems of systems where we may have a digital twin of a construction industry in a local environment, in a city. And all of these things will benefit from greater productivity, greater efficiencies of management when we're able to integrate them.
Yeah. And Miguel Angel, I would like to ask you about these systems of systems that Rafael was saying now, no? How we can do, if it's difficult to have right data in the right time, in a clear and transparent way, etc., as you were pointing out before, how we can ensure this trustworthy of not one system, but a system of systems?
Well, basically, I think that the requirements are the same, but it becomes more complicated. The thing with trustworthiness is that it's something that should be incorporated in the very early design of the system. It's not something that you can consider later, because they might be decisions that affect not only the operation, everyday operation, but it is also affecting how you conceive the digital twin in itself. And when you have several systems, maybe an additional problem that comes is if you want to make them interoperable, then they are exchanging information. And then the problems you have in the edges for a single system, let's say that complicate because there are systems talking to each other. And then maybe this system cannot reliably consider or be certain that this data that is coming from here is trustworthy, or if the data they are interchanging may have a global impact. So having several systems is also a problem of managing the uncertainty that systems interchanging information, let's say, are doing. But if you have a way of making the data traceable and fully transparent in each of them, then it is possible. But the problem is that the weakest link or the weakest of the systems could be, let's say, what is determining the maximum threshold of trustworthiness. So again, this should be considered. There are several systems integrated from the beginning.
Well, this is something very, very interesting, because when we will have to talk about this new culture of digital twins. No? So we have to stop here. We have to thanks to Professor Michael Gribbs, to Miguel Angel Sicilia, to Andrew Lovern, to Pablo Vicente Legazpi, to Wouter Borsboom, to Professor Rafael Sachs, to Peter Pauwels, for this extremely interesting first session. We invite you to, if you have time, to be with us for this next second session that we will open with a keynote by Ioannis Vrilakis. We invited him because he is creating, let's say, or all of us, we are thinking about this creation of real value of what is a digital build, and also this center that has been created in the University of Cambridge called Center for Digital Build Britain is something that all of us are following with a lot of interest. So, Ioannis, I see you here. Welcome for this opening of the second session. Let me introduce you. Dr. Ioannis Vrilakis is the Lane Corrour Reader in Construction Engineering and the Director of the Construction Information Technology Laboratory at the Division of Civil Engineering of the Department of Engineering at the University of Cambridge. So I think I have to stop here, because if not, we will take half of your time for the presentation. But Well, he will talk about construction with digital twin information systems. And in order to be on time, we are beginning this part of the session on time o'clock. So thank you, Ioannis, for being with us.
Excellent. So I have to do the mandatory check. Can everybody see my slides?
It's perfect.
Excellent. All right. So I think it's become clear from the whole discussion so far that this whole digital transformation journey is taking center stage within the construction sector. I mean, there are reports upon reports upon reports that discuss that. This is just one example last year from McKinsey talking about the potential for disruption of the digitalization of construction products. And in fact, that this is happening now within the next 1 to 5 years. But actually, this was with data before the pandemic. Because if you add the pandemic on top of that, that has actually operated as a digital transformation catalyst, with companies accelerating their digital transformation journey and achieving targets that they would normally do in 2 to 5 years in just a few months. So I think that makes this an even more pressing and important topic, that we need to basically create the frameworks necessary to help our industry move forward even faster than we thought would be necessary just even a year ago. On that, digital twins, in my view, are at the core of this digital transformation journey. And I think you've already seen from the presentations before us about what the value is. I mean, there's clearly quite a lot of potential value across all KPIs: cost, time, quality, safety, sustainability, resilience, and so on. But then the key question that comes to my mind is, if digital twins are so great, why aren't they as ubiquitous as physical twins? Why don't we have them everywhere? And my tentative answer is these 4 main bullets. The first one is, we know the physical twin as a product, but we're still discovering the digital twin as a product. And we need a lot more R&D to get to the point where we would have a similar degree of understanding of digital twins as we have of the physical assets, the bridges, the buildings, the roads, and so on. The second aspect is that, likewise, we know and we have been automating for decades now physical twin processes, design processes, construction, maintenance, and operation processes of the physical twin. But we haven't done that for the digital twin. Ways to design the digital twin, construct the digital twin, the twinning process, maintaining the digital twin, and so on. That is primarily mostly manual, therefore perceived as very expensive. Therefore, the value to cost, the benefit to cost relationship is just not there in place yet to allow us to penetrate the market quite fast. So again, a very big need for R&D to create more AI and automation to help the twinning process. The next 2 are more industry related. One has to do with the fact that owners have quite a lot of experience of the value of physical twins, but not of digital twins. And that makes there a very big need for real use cases that can help push for much more rapid market penetration. The last but not least, I know it's a bit controversial, but I think it's the reality, is that vendors throughout the industry are looking to catch on to the digital twins wave without actually doing the work. We are looking one after another, BIM products coming out with slight enhancements, being relabeled into a digital twin product, and as a result, accelerating digital twins as a concept into the trough of disillusionment, which will take us quite a long time afterwards to bring it out of that trough and back into popularity. So how do we solve this problem? Well, on that space, at least at Cambridge and also with colleagues like Raphael Sachs and others, we're trying to do as much as we can on those first two bullets to understand the product and understand the processes necessary so that we can service the market better. On the first bit, on understanding the product, a year ago, we published a paper with Raphael Sachs where this figure comes from, although this one is slightly adapted since last year, that sort of gives you an overview of the relationship between digital and physical twins. We like to use here the paradigm of a person standing in front of a lake, the person being the physical twin, and then underneath him, his reflection on the lake is the digital twin. So you see the positive axis going up is the physical product and process, and the negative axis is the information volume. And so starting from the beginning of time, you have your planning and your design phases from the moment of conception. On the physical end, you have all your design processes going on. And then on the digital end, you have the outcome, which is the design phase, product and process information gradually taking place. This is what we would call the design phase digital twin, or the fetal stage digital twin before the building is actually born. At the birth time, that's when prefabrication starts, which means construction processes start, prefabricated parts start happening. And on the other end of the spectrum, on the information end, you have construction phase product and process information starting to materialize. And then continuing on beyond the weaning phase, when the prefab parts leave the mothership and go to the actual site for installation, which is where you would actually grow your child physical twin into an adult. And at that point, that's when you've reached your project handover stage, maturation, where you have your adult physical twin. And from that point on, theoretically, you are operating it. You have operation processes that are producing operation phase product and process info into the operation phase or adult digital twin. So one of the other reasons I like this figure quite a lot is that it helps us understand from a popular perspective, a digital twin as opposed to a building information model. So the most common perception of a building information model is the thing an architect would give you. And that thing is basically this little yellow line you see there, okay? It is the as-designed building information model at a point in time, let's say times T1, and that's just that little yellow line there, without containing any previous information about how you got to that point or anything else beyond the design data. Now, if I was to extend that a bit further, I would perhaps get your design status model that includes your design phase process information at times T1. Or further beyond that, you would get your as-built building information model containing the construction phase product information. Or going further than that, you'd get, as Raphael was explaining before, the project status model at times T1, which includes the construction phase process information. And that's why we have a problem today, because we have all of these different models, all of them trying to help us understand what's going on with our buildings, hoping to be exchanging data across them, rather than thinking that, well, actually, all of this should be put together somehow. It doesn't matter if it's in a federated format or in another format, but it should be the same graph platform supporting them in the back. And let's say temporarily, we can call that the n-dimensional building information model at times T1. I would still not call that a digital twin yet. What I would call a digital twin is what you see here. It is that information plus any previous value of that information since the beginning of time for that particular asset. The reason I think this is very important, I'll just give you one example. Let's say that at the operation phase, a pipe fails and you want to do some forensic analysis to understand why did the pipe fail. You'd like to know at that point, what was the history behind the pipe? how its dimensions changed, how its materials changed over time, why certain decisions were made and why not. Because oftentimes it is within those decisions you understand why something actually occurred, so you can avoid having that problem in the future. So having said that, some other important suggestions of my own is that I don't think digital twins should have any data in them. I cannot stress that in more stronger terms. Data have no place in a digital twin. Information does. Data is just raw data that may or may not have any information value. And it should be there to help us derive the, let's call it the level 1 most basic information level digital twin coming out of structured and unstructured data, typically held separately and deleted after use. Things like point clouds, things like images, none of that should be, in my view, in a model. Again, though, that would be a very basic digital twin. As through the examples that were presented earlier, what we want to achieve is process that information, look at the information patterns, interpolate, and generate knowledge. And then beyond that, take those knowledge patterns, do some simulations, extrapolate, and as a consequence, generate insight. I think that's when we're going to get the best value out of digital twins. And by the way, to do any of those things, that is actually a perfect use for AI. And that's why the journey of digital twins is inseparable from the journey of AI. One helps the other actually quite well. So this is the journey that we've embarked at Cambridge, both the Center for Digital Great Britain, focusing a lot more on the adoption of standards and defining the digital twins journey at the policy level, as well as my own group that focuses a lot more on can we actually build these things somehow effectively. And like I said, we can't derive insight without knowledge, and we cannot derive knowledge without information. So we have to start at the beginning. We have to generate information level digital twins from structured and unstructured data. And a lot of our work has focused on unstructured data, in particular, things like points and pixels and thermals, because that is in fact a very big challenge. On that space, we've done a lot of work on using basic things like points and pixels on any asset, a bridge, a building, a road, and then from those points and pixels automatically generating the components, registering the textures on top, and then on those textures trying to derive information such as things like condition information and other things that might be of use later. And to do that, we've come up with multiple methods, such as this one, mid-range mobile videogrammetry, allowing us to extract raw geometry from just a mobile phone from 25 meters away with a sub-centimeter spatial error, taking those point clouds, equalizing the densities, fixing the holes, producing generally good quality data sets that are meant for the machine's eyes to see. I want to make that very clear. This is not for the human's eyes to see, because the main purpose is to process that into this level 1 information stage digital twin. That is a big problem on its own. There's been reports upon reports that talk about for every 1 day of laser scanning, people have to spend 10 days modeling. That we are working with point clouds with well over 30 billion points in many cases. And most importantly, it's a very boring job. Imagine someone tried to model pipe after pipe, valve after valve. I mean, the example I have here on the right, this reactor building, 40 billion points. It took 10 people 6 months to make one model. I mean, this is clearly a case that screams for automation. In that regard, we've come up with several methods to help us achieve that completely automatically for bridges in the first instance, where everything is exposed and the number of topologies is small, but at the same time capturing the real world skews and peculiarities of every component, going from this stage, the points and the pixels, into the detected components, and then from the detected components into the actual model outcome. And we've done the same for buildings, trying to capture raw data, converting that to usable information, creating the object-oriented model of that process, going from the point cloud into detecting the rooms and the floors, and then from the rooms detecting floors and ceilings in the presence of clutter, detecting the walls, fitting the components, and creating the actual model. We've recently done the same for industrial facilities, together with Aviva and BP, capturing cylinders, elbows, channels, I-beams, valves, flanges, and so on. A pure deep learning application, which can then be enhanced with contextual information to give us a high quality model at the end of the process. Once we've done that, we can then enrich that with additional information coming from the textures, such as condition information, cracks and spalling and patching and other problems. We've done that for bridges already, where we're capturing quite a large number of defects and their properties and putting them back into the model. And we've also done that for roads, where we're able to capture cracks and potholes and patches and rutting and shoving, measuring that information and bringing that back into the digital twin of the asset. We've also brought in sensor data back into the model to create the connection effect that was discussed earlier today, by modeling the sensors on the components and then bringing the time series data for the connection so that we can see exactly what is happening, in this case from a structural perspective, on our asset as our asset is being used. This is the long-term vision. Basically, how can I achieve real-time monitoring and operation of assets through digital twins, not only at the single asset scale, but at a portfolio of assets and eventually at the system of systems level, like Raphael Sachs was explaining earlier. That's the dream of the National Digital Twin that the Center for Digital Build Britain has been focusing on. On that, we're working on several existing projects, some of which were mentioned already. This one called Cloud Building Information Modeling, that's focused on generating geometry, enriching the product, modeling the processes, and then running applications on top of that. The BIM to Twin that Raphael was explaining earlier, I won't explain that as it was already mentioned before. And also another one called Omicron, which is focusing on doing similar things to the BIM to Twin project, only for roads, going from a road digital twin to decision support tools, to smart construction interventions, back to inspection and back to the twin. So this would be a plan, do, check, act cycle, exactly as Raphael was explaining earlier. Our long-term vision is that eventually we should get to a point where we are looking at assets as a combination of their digital and physical forms, where in the physical versus digital and product versus process scales, we can then combine smart materials in the physical product, automation and robotics in the physical process, data science under the digital process, and digital twins under the digital product. And in doing so, I think we can run our assets a lot better into the future. That's all I have for you. If you want to know more, we published a book recently that covers a lot of these topics. You're welcome to take a look at it. And I just want to thank the people who did a lot of the work that you saw today, as well as the sponsors who funded it. And thank you very much.
Thank you very much, Jonis. Now I understand the Brexit, and we have to ask for a Spanish seat, something like this, in order to make such kind of work as you are making with the CDBB and the university. I think this is extraordinary. And what you show us is something very interesting, because it's not only talking about the building part of the digital twin, but also the infrastructure part of that. And this automation that you are showing us right now is really interesting.
This is just an example, by the way. This is part of our software called Gygax. Gygax is available for free on GitHub. Anyone can download. It's open source, and you can try to work on that. It gives you the ability to play with point clouds, with images, with IFCs, with various other data sets, bring them together, and manage to go from data into usable information within this environment. Yeah. So I'll stop sharing now.
We could be hours and hours. Thank you so much, Ioannis. We are on time, and we will make a little leap to Ricardo Biaggi, that right now he's joining us after doing another meeting with another 500 attendees for DigiPlace, and now you are attending another meeting of 500 attendees for the Building Digital Twin. So today, Ricardo, I think you would be the
busy day.
Yes, a busy day, and the most famous guy right now in Europe today. So well, is your time. Thank you for being with us, and after having this short time between one congress and the other one.
Thank you, Ignacy. Indeed, it is a busy day, but very happy to be with you at the end of this day. So hoping that my screen is sharing correctly, I have some slides on DigiPlace.
Yes, and, we can see it perfectly.
Great. So first, a big disclaimer, a very big disclaimer. Unfortunately, as was said, I was only able to join 5 to 7 minutes ago, and I have had an overview of something which is very concrete, very technical on building digital twin. Even most interesting from where I come from about infrastructure. I am not going to present anything of that sort from a concrete point of view. What we at DigiPlace are trying to do is to develop something much more high level, something a lot more theoretical on certain dimensions. So I would like to walk you through a few slides, including actually starting from a quick video, which will give you a flavor of what DigiPlace is. But first, let me get right into the main goals of the project. DigiPlace is indeed an EU-funded project that started in September 2019 and is closing next week. Today we had the closing conference of this project indeed. Our highest level objective is to develop what we call the reference architecture framework for the digital industrial platform for the construction industry. This is based on a shared consensus and is supported by what we call the strategic roadmap. And I will have some more detail on the RAF, the reference architecture framework, and I will explain in a couple of minutes what a strategic roadmap is. But as I promised, first of all, a pretty interactive, certainly interesting video to present DigiPlace, hoping that it works.
I don't know, Ricardo, if it has sound.
I don't know if the sound is just music, background music, or there is a speaker on.
So I hear you're not hearing the words.
No.
No.
Okay, well, the the presentation was the video was well correctly embedded. It is playing. I don't know what is happening on the words, but I'll
if you
send
want to
you.
comment, Ricardo, it can be enough. If you want to show the video and if you want to say something over the images, it can be perfectly will work.
Well, if you're hearing some audio, then maybe it's not really useful. But I will share the YouTube link to watch this video afterwards. Basically, the video is presenting the let's say the key reasons to start this project with 19 partners. The project involving all the main industrial value chain representatives from the manufacturers of machines, which I specifically represent as CC, but also the manufacturers of products, the civil engineers, the architects, the contractors, the small companies, but all of this supported by an academic partnership. We have Politecnico di Milano, VTT, TNO, other universities in Europe, and we are also supported by the ministries, the competent ministries of Germany, France, and Italy. So this is a long-standing collaborative approach that we started in 3 years ago, which is the first ever collaborative project at this level in the EU side, at the EU level. So we are, with this, let's say, collaborative approach, we try to solve the long-standing issues that we have in a long and complex supply chain like construction. And as I said, this is the first ever collaborative approach at this level, because this is also the very first EU-funded project on digital construction. Some other industrial value chains have been doing what we are doing today 5 or 6 years ago. For example, I know pretty well the agricultural and farming value chain have digitized and have carried out projects similar to ours 5 or 6 years ago. So basically, this was the context and the background. A little bit of the structure of the project. As I said, 19 partners, 21 months from 11 different countries. And we are coming to the end of this project with the main deliverable, what we have promised and what we have delivered to the European Union and to the value chain is what we call the RAF. So a reference architecture framework for a digital platform for the construction industry. The role of platforms in digitizing entire value chains is, of course, under everybody's eyes. The model that this has used in B2C industries like hospitality, mobility, and transport. Of course, you all are aware of Uber and Airbnb. The European Commission is trying to use the same model in complex B2B industrial chains. And this is what we have tried to do with DigiPlace. And we started from the realization that we needed a reference architecture framework, which we believe, which we have defined as a comprehensive set of common guidelines for building and deploying interoperable digital platforms for the construction sector across Europe. So in order to present DigiPlace, sometimes I use the expression of what DigiPlace is not. DigiPlace is not a project to build a new publicly funded compulsory digital platform for construction. The project is about developing this comprehensive set of common guidelines, and we have different types of guidelines. There are general guidelines for implementing the digital platforms. There are guidelines for tools and services that they need to be still developed and generalized to support certain key use cases. And of course, there is a special focus on what is the role for public services. And since we have 3 competent ministries in the consortium, that was a key goal and, in my opinion, a key achievement. the purpose of the RAF was to, as I said, develop a framework, develop a set of guidelines to create a comprehensive and structured vision, and also to highlight the interconnections that exist between the references. We want to use this to improve common understanding of ongoing evolutions, but also to educate each other, ourselves, on the potential for digital platforms in the construction industry. We also want with the RAF to identify the gaps in the current landscape and the actions to be carried out to fill those gaps in order to facilitate the development of platforms. Indeed, let's say the platform economy in the construction industry is not very well developed, but it has already started developing with the role of certain private actors in developing very specific digital platforms for a specific area of the construction value chain. There are a couple of publicly funded projects existing in countries like France and Italy, where digital platforms were put at the service of the value chain. So the idea of integrating those reflections in the project was also key for us. We want to try and create a level playing field for all the construction stakeholders, including the digital service providers, which are more and more newer actors in the construction value chain. And we also want to understand what are the tools for the RAF, for the reference architecture framework, and widely for the digital platform model in supporting the policy objectives, or anyway the underlying objectives of the industry: sustainability, more productivity, better competitiveness, creating or furthering the single market in the EU for construction. So this is what we came up with. This is a high-level scheme, a high-level structure of our RAF, and there are, as you can see on the top level, are area-specific guidelines which we have identified in what we call the mapping of use cases, of key use cases. There is an area for environmental performance. There is an area for data sharing. There is an area for business market and collaboration. And there is an area for public services and initiatives, areas where, for example, we have widely discussed building permits, interaction between contractors and public procurers. So this is the area-specific guidelines, which, let's say, come a little bit on top of what are the core guidelines, where you
Ricardo,
can find
last minute.
Where you can find interoperability and control over the use of data. This is, of course, all built on top of what we have as the regulatory framework. I think you all know, and you will all agree, that our industry is already widely regulated, not always at the right level from a geographical point of view, with a lot of national regulation coming on top of a lot of European regulation. So we have tried to take that into account by, once again, including the role of public authorities in the reference architecture framework. I'm going to conclude by inviting you to get involved if you want. If you take out your mobile phone, you can take a QR picture of your screen and register to the DigiPlace community of stakeholders. Of course, this may be surprising because today we have had the closing conference of this project, but today was also the way to relaunch the DigiPlace project with the next steps. So I invite you, if you want to give us your opinion, your thought, or get involved in the future of digital platform for construction, to log in and join our community of stakeholders. Thank you very much for having me, and thank you very much, Ignazio, for inviting me today.
Well, thank you for being with us, Ricardo. It has been very, very interesting. And of course, we will be trying to be part of this DigiPlace project. And from Brussels, let's go to Gabor Siavik. And this is something really interesting for us because he has CV related to IEEE, and also about control, robotics, mechatronics, etc. And let's see how this approach to BIM is something that we can begin to touch from Norway. Thank you, Gabor, for being with us.
Yes, thank you very much for the kind invitation and the introductory words. So my name is Gabor Sivig, and I will be mainly focusing my speech today on this changing the rules of the construction. So what is our goal here is that we would like to expand the static BIM with dynamic information that is coming from the construction process. So the presentation that I will be doing here, it is connected to the second round of the digital twin call in the Horizon 2020 frame, and I'm the coordinator there. But let us start with a very short introduction on itself of what we would like to achieve with the project. So, of course, the focus is in digital twins, so improving building information modeling by real-time tracing of the construction processes. And for this, we have many different tools that we proposed in using in the project. These tools are kind of enriching the information in order to establish a twin, and also tools that are helping us to communicate this twin information out to the users. Let it be either construction workers or emergency personnel or site manager clients from the general contractor side. So it's a very kind of wide scope for the project itself. But today I will be focusing here on how to create a digital twin based on BIM information. So let us start with that. We should introduce very basic rules when you would like to create traceability on twins and digital twins. So first of all, we would like to start from a known position. So we want to have a kind of an information already started at the day one of the construction site, that what will happen and when. So this is the very first thing that, at least from our point of view, when we want to create a digital twin, we need information about the events that are supposed to be happening. If we have this, so then we can start building a twin. The second one, that all the revisions that are happening on the as design phase, we need to have a traceability on it. So any changes on the geometry, any changes on the timeline, we need to have it kind of traced on the BIM models itself. So we would like always to have a trace of the changes, not only that you provide a new revision, but we would like to change and see that what was changed. And in order to do this, we also introduce new properties that are always kind of following up all the parts that are deleted, that are added, that are altered. So we have always a very good traceability of what was happening. And the third, that we would like to also to include in the twin itself workers, machines, robots, drones that are in default not part of the original BIM IFC documentation. So all that things that are happening on the construction site, we would like have traceability with the proper unique identification. And if we keep these rules, these really simple rules that we would like to trace, so then at the end of the construction, we will be having a really good overview of what was happening on the construction site itself. And what the twin is, at least in our interpretation, should include, and this is related to also the keynote that was presented here on the level one, the information for the digital twin. And this is that we provide a timeline. So you will be like on the YouTube, you will be able to kind of go back and forth on the construction site and always know that what was happening there. So we create a timeline on the construction site that will be the part of the digital twin, includes all the information. Let it be either a task, let it be a kind of a construction step, let it be a resource. So robots, humans working there in this kind of timestamp way, so time-based database information, everything included there. And in addition to that, we also know and we also kind of follow up where are the workers on the construction site. So based on their location, zone-wise, not precisely, because to keep the privacy of the worker. So we are able to actually follow up that work need to be done and that was actually done or not. And we have also in possibility to introduce inspection rounds, so we can send the robot on kind of a mission to do the mapping and to look around. So these are all part of the digital twin itself. And how we see for us that how this will work. So first of all, we start with the design phase, where we know that how the building will look like. These inspection rounds result in a kind of, we can call it in as-built check, where we can find the deviation. When we define the deviation, this can be a result of a laser scan, for example. So we will clearly be able to identify that in the BIM model, there is a difference, there is a deviation. And if we know that there is a deviation, so then we are actually able to say that, okay, these are the two elements that have changed or wrongly placed, and this is not how it was built. Then we are able to, in the next step, say that, okay, actually one of the dimensions are not properly set. And then we can say that, okay, this dimension is wrong. So what would be in a normal world should happen is that we kind of communicate this information back to the owner of the IFC file. So for example, the architect will get an information about that, okay, the dimension of the wall, it was not that as it should be. And then we communicate back to the designer that, okay, you should do it through BCF communication, so that you should update your whole design and give us a new revision. However, this is very time consuming. So what is our focus is that actually we do a kind of, in a computer science word, a kind of a forking here, that we kind of split the model into multiple stages, so that from this point, the twin has its own separated life with the introduction of a BIM-proof property, that we are actually storing multiple copies of the identities of this BIM information, and until it is not proved, it is only just existing in the digital twin. So if we would kind of describe that how a twin works in our system, is that in the very beginning, our digital twin that is developed in the project is at the beginning, it is synchronized with the as-designed files. And then we, for example, receive an update from the architect that, okay, I have changed the dimensions of the window. This information is automatically kind of updated in the twin, and also stored in the as designed officially contractually binding information for the whole construction, or for the building asset. In the meantime, we are doing the kind of the daily tracking of the construction site, and we figure out that there is a kind of a deviation. So that one is kind of highlighted here with the green as built update. So we find deviation and even more deviation, which are in default only approved in the twin side and not in the contractually binding as design model. So we kind of informate and store these kind of deviations in the twin itself, and notify the owner of the model part that, okay, this has been changed, so you need to have an action with through a BCF information, and that you need to change your design officially. And until this is not done, this exists in the twin, but it is not binding totally as a contractual wise. But we submit these BCF also to the designers, and then we get, as soon as we get the approval, we introduce these back to the design phase itself. So that is what we can say, that our twin is very much focused on the legislation part. So focusing on that, who is the owner, where it is coming from, and how we can introduce changes in a dynamic manner and get it also used in the contractual point of view. And these details we have been already published in a white paper that is focused on the digital twins and the data integration for the IE code sector, which can also be accessed from the following QR code. Behind the BIM-proof project, we have 12 partners, leading scientific research organization, and also major industrial actors, and also standardization actors in this frame. So get us touch with us, and this would concludes my presentation, and thank you very much for the possibility.
Well, thank you for your presentation, Gabor. I think it is enlightening us a lot about these possibilities about this. Also, what Rafael Sachs and also what Ioannis Vlakis were telling us about automation, about this and how robotics can be one of the solutions for that. No? So thank you so much. And now is the turn of Bruno Daniotti. He's coming from the Politecnico of Milano, and he will explain us about building renovation digital twins, as you can see in his presentation. So, piacere, Bruno, per essere con noi. Avanti.
Good afternoon. Thank you, Eduard Roskos and the Sphere people for this kind of invitation. Just to introduce myself, while I am managing, of course, of building process information management through the last 20 years for Politecnico di Milano, and I'm the coordinator of this project, BIM4EB. I speak about this, but just a few words. 20 years ago, just founded the Building Smart Italy in Italy with other colleagues of mine, and participated to the European project Stand-In, chaired by Sintef some years ago, and have been responsible for different projects for, let's say, the use of BIM in the construction sector. Of course, today I speak about our project I am managing. I'm focusing on the building renovation activities, and the goal of the project I'm chairing is about to develop a BIM-based toolkit for efficient renovation of buildings. And the project is ongoing and will conclude in the next summer. You see 15 partners from different countries around Europe, and some university, research institutes, public administration, focusing on the activity on the public sector. We are focusing on the residential buildings. That's why Region Lombardy is participating for some demo sites. The goal is to develop a BIM-based toolkit in order to manage renovation activities and to improve efficiency, to decrease the working time, cost, and also to improve performances, quality, and comfort for inhabitants. That's the focus also for the inhabitants, the occupants of the buildings. Some specific focus are related with the reconstruction of the BIM models using IFC, of course, open interoperable models for existing building, integrating semantic data, ontologies, and linked data. We have seen with an example with Peter Powers, we are also using these technologies to include also information coming and data coming from the buildings, the real buildings. And also the focus is to manage everything with a BIM management system organized as a common data environment. So at the moment, the project has been developed a preliminary analysis of needs of information requirements with the stakeholders, and a big focus is about developing ontologies and big data to manage the activities. In the second phase, we are now closing. The toolkit has been developed. So as by focus, of course, the BIM management system, gathering all data and exchanging more data, also the linked data. Some tools for the fast mapping and survey on the building. Some others are for the planning of the activities, and some others for the managing information about equipments and so on. And everything is now applied in the demonstration phase and 3 buildings, actual buildings in Italy, Poland, and Finland. So the toolkit is focused with a core BIM management system in order to share all the information in an interoperable way. On one side, we have the activities related with the managing of data, so the fast mapping of the buildings, the actual buildings, BIM planner to manage the works for renovations, and BIM for occupants to share this information with the occupants of the building. On the other side, we have some tools related with the efficiency of energy efficiency of the building. Some areas is related with the management of let's say control system automation and equipment, and BIM CPT is about heating, ventilation, and air conditioning management. So the BIM management system is managing all the different data coming from the applications with the different layers for the exchange of data. So the models in IFC models, also using IFC overall just to consider the linked data technologies, IoT stream data coming from the building, and GIS data to manage the information at the geographic level on the building. So in this case, we see the one example of the IFC of one building or another, managing also the linked data on the data coming from the sensors on the specific apartments on the building, where it's possible to keep this data and to manage, to share this data with the occupants in order to control comfort and energy levels in the building. One example of the tool is the fast mapping tool, where we have use of laser scanner in order to gather all the geometrical data from the buildings and to convert this data into IFC file in order to reconstruct the as-built of the building. And a specific sensor stick has been developed in order to detect the materials and installation inside the walls. So, for example, specific types and so on, and augmented reality tool in order to visualize the 3D mapping of the building while managing on site the building. So the results, of course, are the BIM reconstruction of the apartments, plus the specific, in this case, that's an example, the specific structural parts which are not visible but are inside the building walls. Another example is related with two tools, which are BIM Planner and BIM for Occupant. The focus is to manage the interaction between stakeholders while developing the renovation activities. Problem is about preventing the conflicting activities in the apartments with the management of the information from the contractors, the owner, and occupants and owners in order to ensure health and safety during the renovation works. So that's why we have developed in the toolkit the sharing of information between BIM Planner, which is about the construction management, the owners managing through the BIM management system the information, and a specific tool developed for sharing the information with the occupants, before occupants, in order to keep informed and take into account the availability of the apartments for the occupants. That's the example coming from the BIM Planner, coming from the building model of one of the building. This is the part of definition of the activities, so the scaffolding, and the location, the work location of all the activities for each apartment. in order to share this information between the facility manager, the owner, and the occupants. And when all the locations are related with activities, of course, the planning, through the whole week planning of the activity in order to share this information. Of course, this information is shared with the BIM4 occupants, where the specific occupants of the apartments have information about the comfort conditions of the apartments, can manage the plans, but also manage all the information related with the renovation activities. For all the information, of course, you may have a look on our website, where you can have also all the videos for the presentation of the whole toolkit for developed by the project. Of course, as I told, some parts of our project may be used in future as, for example, for developing digital twin, and we are developing, of course, research going towards a digital twin. So thank you.
Thank you so much, Bruno. It has been a very nice intervention, because at the end we have to try to make a link with this new renovation wave and this new Green Deal in EU. So this is something that we will have tools for that. So thank you so much for this information, and hope to see you again. And now it's time for Sergio Velázquez. He's coming from another sector, because he's senior chemical engineer, but he has participated in more than 10 digitization projects in different areas, and he's developing a lot of different EU programs with the Polytechnic University of Catalonia as an associate professor, as project manager in the research and development area of the IDP, Ingeniería, Arquitectura and Medio Ambiente company. So now it's time to know more about a Sphere project. So thank you so much, Sergio, for being with us.
Thank you very much, Ignacio, for your introduction. And so, as you have mentioned, I work for IDP, and I will specifically talk about the Sphere project. It is a pilot project about the first digital twin application for building, and I will be focused on some of the definitions made in this project, and the role of the digital twin manager, an actor that have been defined among others within this project, because this role is very important to get the final outcome to produce digital twin in the building sector. First of all, I will make a brief introduction to Sphere project. Sphere project is an European funded project by H2020 instrument. Is composed by 18 partners from 10 different countries. IDP is the leading partner, and the aim of the project is to develop a BIM-based digital twin environment in order to optimize the building life cycle, to reduce cost and improve energy efficiency in residential buildings. We are considering some pilots where we have a different kind of buildings. Some of them are for renewal, and other projects are for new construction buildings. So the idea is to apply the Sphere results in different kind of buildings. As you have been hearing during this session, the concept of digital twin is a final extension of the digitization process we are suffering at a global level. So it is important to see how this concept must be applied to the building sector and construction sectors, in order to get this digital twin in the different layers as they have been defined, starting from the design and construction of the project. Then we obviously have to go to the definition of the instances in order to create all of the assets and the elements in a digital manner in order to try to get the operation and maintenance operations at the end. And obviously this living twin must grow in terms of the aggregates and finally the digital twin environment in order to make it interrogative and predictive for the whole life cycle of the buildings. In general manner, this is a global view of a digital building, but in terms of the different stages of the project based on the different tools, software, and the instruments we already have up to now to produce the construction projects. So this is an advantage because many software companies have developed different software and applications that already works really good in order to get three-dimensional and other information models about construction projects. So the question is how to integrate the information provided for these different solutions in each specific stage of the project. We start since the conceptual design of the project. We also have two other stages to create the project in itself, to create the documentation. We have to start the construction stages, and then it is important to have information about the operation and maintenance of the building. At the end of this life cycle, it is also important to know how to give the final outcome of the building. It is possible to be renewed, or at the end it must be destroyed. But obviously, all of the information must be collected in some place. In terms of the Sphere project, we have made the same approach. We have created a large consortium in order to get different actors to provide solutions and tools in the different stages mentioned before. We have tools that will be integrated in a digital twin environment that will provide suitable solutions and services to the different actors in the digital building construction in order to get the information in these different stages of the project. So here you can see some of the tools. We have tools to manage first the information model of the building. It can be an IFC model or any kind of BIM-based model of the project. And then we will follow the different stages from the construction till the end life of the building with the sensors installed in the facility. To get and reach this kind of projects from the Sphere context and the Building Digital Twin Association, we have defined three key actors that must be in charge in the development of a digital twin project, a building digital twin project. And those actors are the digital twin manager, the digital twin configuration manager, in order to get that all of the information that is flowing through the project must be in accordance to the standards and the requirements of the integration platforms and the interaction with the different tools and software that can provide information to the model. And finally, we also include the digital twin simulation manager because a part of the monitoring of the assets and the design information, we consider that including information about some parameters to follow and to control the performance of the building must be previously simulated. Focused on the figure of the digital twin manager, it is very important to say some things. From our point of view, the digital twin manager must be the orchestrator of the project. It's the person who directs the processes, the different processes, in order to get that information flows, and the information must be in the proper formats and integrity and safety and security, in order to be the final versions or the accurate information that the other stages of the building digital twin construction requires. It's important to point out that we don't really know which kind of training or expertise must have the building digital twin manager have. In that way, I am making these basic questions. Must he be or she an architect, and civil engineer, a software engineer, a BIM modeler, a scientist? It's a really complex question to answer. Or maybe it can be a person, a team, or an expert supported by a team. So it is very important to say, because it is a very complex work to create a building digital twin environment, and obviously it is very important to define this role accordingly to these needs. In any case, it is a multidisciplinary and horizontal role within a digital twin project, and this actor must have some competence that make possible that this building digital twin manager interact with the digital twin simulation manager and the digital twin information manager, obviously. We also have created the idea that within the SPHERE project, we can extend the concept of BIM execution plan to the digital twin execution plan as an instrument, making the same analogy with the director of the orchestra. This is a very good starting point in order to extend the 9 dimensions of a digital twin project, because we have extended from the typical 7 dimensions on BIM projects to these other 2 dimensions. Those refer to the safety and security of the information, and then the link construction, in this case, taking advantage of the SPHERE project results. In a vertical manner, we have created or adapted the information design and delivery methodology in order to create information workflows among the different stakeholders and partners and people involved in the creation of a building digital twin project. From the SPHERE context, this is the general idea of the building digital twin platform we are creating. The name we have given to this integration platform is the SPHERE API, where the different users must access the API with a previous authentication and authorization in order to provide the security and safety issues. In this case, we are included a blockchain service in order to validate this access, and in order to manage and control the different information that is flowing within the digital twin environment through this API. As you can see here, we have established three different stages in the creation. One of them is the configuration of the modeling itself, where we are collecting the asset and geometry data of the building project. Then we also have to use an IoT platform in order to collect information coming from the sensors, and the other information coming from the files and documents referred to the different stages of the project, for example, smart contracts, or information about the elements installed and the materials employed during the construction project. And the
last
final,
minute, Sergio.
Yes, nothing.
Last minute. Yes.
Okay, may I continue?
Yes, sure. I was saying that last minute.
Oh, okay, okay, yes, I will finish.
Thank you.
And finally, we have the other element, which is the digital twin platform, where all of this information created and collected here is integrated. Here you have all of the sensors I mentioned before, and these are some of the visualizations of the different platforms we are using in the Sphere project. This is the NeanX platform, where all of the geometry and assets information is collected. This is the results coming from the simulations made in this case for heating and ventilation systems within a building. And this is the integration platform with some sensors installed in order to make monitoring and including information about maintenance of the building. And that's all from my side. Thank you very much.
Thank you so much, Sergio. This new role of orchestrator, I think, is something very, very, very nice. Well, we have finished with Sergio Velázquez, and we will continue now with Sergio Hugueto, and he's from the BMI for the Barcelona chapter. And well, Sergio, if you want to share your presentation.
Okay, thank you very much, Ignacy. I will share. Can you see?
Yeah, well, now it's been uploading.
Okay.
Right, yes, right now.
Okay, I will show from the beginning.
If you can put it as full screen, right, perfect.
Yes, yes, yes. I will stop the camera because my internet connection is not so good.
As you prefer, Sergio.
Yes, okay, I'm not sure, but okay. Thank you very much for the invitation for this event. Until now, there were a very interesting conference about the technical side of the digital twin. Then as Ignacy said, I'm the president of the PMI Barcelona chapter. From the Digital Twin Association and PMI, we have a partnership, and in our association, we share information about digital twin. I would like to take you some minute to speak about PMI. And I had said I will speak about the human side of the project. At the moment in the PMI, we are more than 300 chapters around the world, more than 500,000 active members. We have more than 1 million PMP certificates professional management certified. That is considered the best certification in project management. And currently we have more than 10,000 volunteers around the world. For the certification, we have a certification, let's say, project management professional, and another certification that complete the professional project manager, like business analyst and portfolio and program management, risk management, and all a new set of certification in the agile world. For the Barcelona, Spain chapter, we have 3 main strategic objectives, what are the development of the chapter, the development of the personal and professional members, and the relationship with the community. And in our area, we are working on membership, partnership, like we have with the Building Digital Twin Association, project with the community. For example, we work with some ONG to help them to get results in their projects. And one thing that I would like to share, that we have a community of practices, and one of the community of practice is constructed. Can you hear me well? Because I have some echo.
There was some echo, but
okay,
probably you have some.
Now it's okay. Now it's okay. I'd say we have this community of practice in construction where all PMI members discuss about construction, how to manage construction project. And as well, we have event, communication, volunteering, and particular a personal and professional area that we help to all project managers to grow in the profession. Now, for the digital twin management, there are a lot of things to speak, and I will not speak about the technical side. I will speak about just very shortly about the human side. For the PMI is defined the talent triangle. This is the skill that the project management need to get the result from the project. Think about when we are leading a project in the construction area. See, it's not enough to have technical knowledge or just leadership knowledge or just business management. Then I will speak about some details about it. For example, in the technical skill, it is necessary to be able to manage the complete project. Yes. And one thing very important is the scope of the project, to be sure that the project will deliver that is defined from the project and will be made only the activity that is necessary to do. We know in some project or so many projects, there are so many activities that don't give any value to the project. This is because the scope has not defined it correctly. Another topic is the schedule management. To be able to get the result of the project, we need to go through the phases or stage or these steps from the project that need to be defined. Sometimes has the contract in place for this schedule management. Another topic is the cost management. The project management need to manage the cost of the project. The project manager need to know the financial aspect of the project to be able to get the resource in the time from doing the activity. Another topic is quality management. This is important that every task and the result that we get, the project manager can ensure that is the result, the delivery of these tasks meet the quality defined. When we speak about the resource management, we are speaking about from human resource and technical resource and resource from another type, like property, intellectual property or software or all the resources that are needed in the project. Another important topic is communication. The project manager need to be able to manage the communication inside the project and outside. And this is related to the stakeholder management. From the project management, we need to be sure that the project manager need to manage the stakeholder, the engagement, the stakeholder, to know which is the power of decision, the stakeholder, and which are the expectation. As you know, when you define a project, there are from some stakeholder big expectation, and we need to be sure that the delivery of the project will meet this expectation. Another topic very important is the risk management. From the risk management, we need to be sure that all risks were analyzed and prepare contingency action. This is a risk occur. Finally, is the procurement management that is related to the cost management to be able to get all the products that is necessary in the project in the correct time. Now, I just say the first part of the triangle is a technical skill. The project manager need technical skill about the project. It's about technology and tools to manage the project. But this is not enough alone. We need a leadership skill from the project manager. The project manager need to be able to have, like described, he has a set of leadership skill, like critical thinking, logical thinking, problem solving. Think about all the problems that is day by day we have during the project execution. Conflict management, decision making, managing remote or virtual teams. Now, with this situation that we are living now, this become a really important skill. Has is teamwork and collaboration. From collaboration, we need not only to manage a specific tool of collaboration, sino to get some guidance to the people. And
Sergio, last minute.
Okay, the first part of the talent triangle is about the business strategic. Now, just 1 minute. This is the most important thing that we like to say. Think about, I have the pleasure last year to know about the project Sphere. And in every step, when you are speaking about the Sphere project, there is that the 3 managers that Sergio described before me. And for each of these area, there are activities that the project manager can work with. This relationship between project management and the digital twin solution. I said that if everybody wants to know more about how a PMI can help to implement or to develop the skill around the digital building, the digital twin building, then can contact us, our website, or my email. And finally, the last word, thanks to Edward to invite to a PMI to give some minutes to share the human side of the project management. Thank you very much.
Thank you, Sergio. I think it has been a very good approach to this human side of the digital twin, and also this training ways or guidelines that you have in the Institute. So we are now closing this second session about new horizons for building digital twin, and we will close it with Dan Isaacs. He's the Chief Technology Officer of Digital Twin Consortium, that in fact is our reference in the world, and is something that I will ask all of you to check their website. So Dan was Director of Strategic Marketing and Business Development at Chillings, and also he has been responsible for new emergent technologies about AI, about machine learning, about IoT, about automotive business, etc. So Dan, is your time, and thanks for connecting from San Francisco right now. So thank you so much for being with us.
Dan, I'm afraid that you have the mute on.
There we go.
Yes, that's perfect. We see you.
Thank you so much. I really appreciate the opportunity to present here. Can you see my screen at this point?
Yes.
Excellent.
Perfect. If you want to make full screen, probably.
It was going full screen.
Right, perfect. Thank you.
Excellent. All right. So I'm going to basically give a quick introduction here in terms of the Digital Twin Consortium. Again, thank you for inviting me to present here. So my name is Dan Isaacs. I am the Chief Technology Officer for the consortium. And I just wanted to start off with this slide, really because I think it's really profound in the statement that by linking the physical and the digital worlds, you can generate over $10 trillion per year in economic value by 2025. And we're starting to see that being recognized across many different market segments. And one of the key points of the Digital Twin Consortium is to drive the adoption and the interoperability and the development of digital twin and digital twin enabling technology, and look at it from a consistent level of approach for open source and open standards requirements, committed towards accelerating the market and really guiding outcome for users. So looking at improving interoperability, really driving the adoption of digital twin, and being able to demonstrate the true value. So we were founded a little over a year ago by Microsoft, Dell, GE Digital, Northrop Grumman, Lend-Lease, as well as the modeling Ansys, Autodesk, and Bentley. And you can see here we started with a little over 50 members. Now let's fast forward a year, we're over 300 members and continuing to grow. Sometimes I'm seeing them come in, the membership requests coming in on a daily basis. So it's tremendous, and it's a testament to the recognition that digital twins are the key enabler towards digital transformation. So how are we doing? How are we going about accomplishing this mission? We've separated into key working groups. We have our technology, terminology, taxonomy working group, more the horizontal focus. So think about security across every digital twin. The lifeblood, the lifeline of digital twin is data. You need to get access to that data. You need to run analytics on it. You need to connect. So security is paramount. On top of that, there's trustworthiness, the resiliency, the reliability of the data. And in other cases, obviously in healthcare and life sciences, the privacy of that data. So what we want to do is we want to look and have a common language, a common vernacular to speak and understand within all the consortium and have a common terminology. And then also look at it from a reference architecture and look at it from a platform stacks, and then look at open source opportunities through there, and then look at the specific domains, the vertical areas, whether it's aerospace and defense, manufacturing, natural resources. We've actually added a healthcare and life science working group, and of course, infrastructure, which is all about buildings and smart cities and all the infrastructure. I'll talk more about that. And then with our thought leadership and marketing team. So the first thing we've done is we've established a definition, a consistent definition throughout the consortium. We've published that along with a glossary of terms. We've also created a reference architecture, so this platform stack. I think here you can see the key elements: security, trust, governance, the foundation, and then bringing in the convergence of the IT and the OT and the platform. What does that look like? And how does that interact in terms of the virtual representation? And then the services and the microservices. And then how do you interface that along through the synchronizing the mechanisms of getting the data to and from real world to that virtualization? So as I said, we are very domain, very vertical oriented. So we have both aerospace and defense, healthcare and life science, manufacturing, and infrastructure. And if we take an example within infrastructure, we can look here, we can see this is chaired by one of our steering committee members. So this is from the CTO for Lend-Lease, significant major property management, construction, and overall building association. So this is Lend-Lease. And Sala Eckhart, also a very key responsibility within Microsoft as related to buildings, real estate, all the management through there in terms of ontologies and those aspects. And then we also have the VP of GAFCON, who is representing the owners themselves. So one of the key points about the consortium is we have both the technologists, the users of digital twin, the developers of digital twin and enabling technology, as well as academia and government and research. And you can see here, looking at it from the infrastructure standpoint, it's not just about smart buildings, it's about smart cities, it's about the infrastructure, the bridges, the roads, the rail, the tunnels, all the transportation aspects, and even autonomous systems as part of that, including things like traffic management and people flow. And this is one of our members. This is the chair of an organization called the Autonomy Institute, and they're looking at across the board in terms of creating these smart cities and the corridors for the transportation. And that would include areas in terms of air as well as land and even sea. So if you look at this, and this is a quote from the CEO of Esri Singapore, only with a digital twin in place can government agencies effectively analyze what can be done with the data. What is the actionable insight? What is that data telling? And improve the living and create the opportunities. And we're talking not just a digital twin from that standpoint, we're also looking at it across the supply chain itself. So from when the goods come in, how do they get transported through the city? How are they managed effectively? And so digital twin from a supply chain perspective, so covering production, supply, the assets, the logistics, all of these different areas tying in. And then another working group is really around our natural resources and looking at it in terms of using alternative energy to be able to generate electricity to power these cities, to power the buildings. We actually have a pilot program right now running where we're actually looking at the buildings as batteries and what is the implication there. And that is all actively managed through a digital twin. We also cover mining and oil and gas areas. But this is an example here. This is part of that pilot program I was referring to, where you're using a digital twin to create that utility infrastructure so critical to powering our cities, to powering our buildings. And in this case, we're actually looking at it from a perspective of not just a digital twin around the alternative energy to create electricity, but it's also the high performance compute necessary to manage that. It's also the high speed communications, both wired and wireless, to manage that. And you can see at this level a very indicated example of this where you're decentralizing the grid so that these cities can operate autonomously and they won't be brought down by one single event, whether it's an attack of nature, lightning strikes, storms, or whether it's a cybersecurity attack or a physical attack. So decentralizing that to allow these towns and cities and villages to be able to support their own energy production and be able to operate from that way. But then you can link those together and create state. You link those states together and you create regions, districts, and link those states all together in districts, and now you can create countries. And that's exactly what is going on. So we're looking at it from an overall infrastructure perspective and have a digital twin actively manage at each different level and levels of complexity, levels of additional functionality, again, relative to being able to power the buildings and the cities. But it goes even beyond that, looking at that from a perspective of now taking that electricity that's generated from whether it's solar or wind or hydro or geothermal and use that electricity to be able to then create alternative fuel and create green hydrogen. And we're seeing this adoption across the globe. So very exciting, very great opportunities within the consortium and looking at all these perspectives in terms of being able to supply that energy and allow our cities and our buildings to operate. So on this alternative generated electricity. So within the consortium, we have many member initiatives running in place. We have a digital marketplace that's ongoing now. We have an open source initiative. I'll talk a little bit about that in a second here. We have the use case reference library. So remember we said we were going to be focused on guidelines and outcomes. So these are all examples, taking a case study of an implementation, an example, and showcasing that and creating these guidelines, the learnings from them. And then we also have what we call our innovation platform, where we talk about the thought leadership and the unique innovations that are transformative in terms of the business outcomes for the value that a digital twin provides. And then we have an ecosystem activity where we're both working with many other organizations. Think about it, we have a relationship with the Smart Water Foundation. So all the municipalities, major municipalities around the world, how does a digital twin affect in terms of water management, water quality? So bringing that all together and bridging that in terms of collaboration and opportunities, and even on regional basis. So this is our open source. We just have announced this, and we're actually now receiving several different proposals for projects so we can continue this expansion and drive that adoption of digital twin and digital twin technology. This is directly on our website. And really then looking at how we can collaborate closely with the Building Digital Twin Association and bring some of these opportunities together and leverage some of the great work that's going on with Sphere and bring these opportunities for collaboration and work together jointly on these areas. So if you're interested in hearing more, which I hope you are, please, you can go to our website. There's a lot of information in terms of the activities. We have a channel where we have several different webinars on very specific areas. And then we also are involved in many, many activities. You can see here, every single month, there's something that the Digital Twin Consortium is involved in. Again, this opens up great opportunities for collaboration with BDTI. So for that, I want to say thank you very much, and I appreciate your time and the opportunity to present and introduce a little bit about the Digital Twin Consortium.
Thank you so much, Dan.
Thank you so much, Dan. I see that you will be from October 5th to 7th in Barcelona, so probably we could meet.
Absolutely.
If you are coming.
I would welcome that.
Yes. Thank you so much. Only to close this second session, and in order to give the word to Eduard and Peter Imbrecht to close this congress. Only some data. We have been for more than 3 hours with 17 speakers. We have had 17 great presentations, more than 500 attendees between YouTube Live and Zoom, and more than 400 different slides that are talking about the future of a new association as the Building Digital Twin Association. So, Eduard, Peter, is your time, and thank you so much for all the speakers and taking your time for the preparation and being with us this afternoon.
Well, thank you for. Can you hear me? Yeah. Okay. So yeah, I'm not going to take too long of your time because as Ignacio already said, we are now 3 hours and a half running, and we had 17 presentations. So first of all, I would indeed also like to thank all of the presenters, because I believe it was a very interesting panel, very international panel, and I heard a lot of very good insights for different subjects. I just want to talk about a few things. What I heard is like the insights for the opportunities that we can see for digital twins, and I've listed a few in here, but there are so many opportunities, and I also believe that what Dan also pointed out, the quote from McKinsey, that there is like about 10 trillion worth of value of digital twins to connect all the dots together. Well, I believe that is absolutely true, that we are only at the beginning of what we can see for digital twins. And as also Michael Greaves pointed out, the rise of the digital natives, it has yet to begin. And so we are all, we weren't born using all the digital tools, but our children, yeah, they are just born in an era where everything is digital and it's very, very natural to work with. So I'm very looking forward to the next decade to find out what is going to evolve. But next to all these opportunities that we have learned about the last couple of hours, there are also some challenges to achieve those opportunities. And well, they were also pointed out in many of the slides and the presentations of our panel, like for example, the robustness and the trustworthiness of the data, but also the challenges that we have with interoperability and how to set up an appropriate digital twin landscape. There are a lot of challenges coming around, what you always tend to see, because you also have the new roles and new skills that we need to develop, but where it always begins, and that's something that is coming everywhere, not only in this Congress, but also in many other Congresses that I've attended. It's the open standards and the need of standardization in our sector. Because what we really need to be able to do is to exchange that information in a very quick and easy manner, and make sure that data is computer interpretable. And also because thinking about those opportunities of machine learning and artificial intelligence, if data can be interpreted by the computers, those kind of opportunities get a lot easier. So it's really important to get like that standardization level, let's say. And what we see in the market is that there is like a scattered landscape of a lot of initiatives around standardization, but as well, like we heard here today, and we saw different of the European projects coming by today. That a lot of the different projects, of the European projects even, and next to the European project, you have also the Digital Twin Consortium that is international. For example, Building Smarter is also international. They're all working on standardization and working on those basic ontologies, the language that computers speak, let's say, and to grasp all that knowledge and information, to make it possible to share all that information. So I think out of the Building Digital Twin Association, we really want to enable the co-creation. So I would really like to see that in the next steps, how we can join forces and take all of those learnings from those different initiatives and put them together to offer the market the level playing field we're all looking for. As Edward also stated in the opening session, we are working on some next steps with the Building Digital Twin Association. One is the second white paper that is ongoing around the simulation across the building life cycle. But next to that, we have also started up 4 working groups. I will repeat them very briefly. So one about the definition and roles. What kind of roles do we need? What kind of definitions do we need, etc., to get like the first cornerstone. But as well the open technology framework, and that's also something that is coming back in different initiatives, like for example the DigiPlace, or just like in the Digital Twin Consortium, where we want to enable software suppliers and vendors to create an ecosystem around those digital twins. A third working group is around the digital twin aggregates, about interoperability as well, but also to stretch out to digital twin cities, etc. And of course, the simulation is also one important part of the digital twin consortium, the digital twin developments that we are doing with the Building Digital Twin Association. So I would say feel free to join, because we could use your input. I believe it's very important. You can send us a mail, and then we will get back to you soon. And to finalize, please join as well as a member. There are 2 kinds of membership at the moment. We have full members and associate members. So to keep really the barrier low to join, I just would like to reach out, join us and help us to make next steps towards a world where we can share information, build up digital twins, and go for that 10 trillion of value that we can generate. That's it. That was it for my part. So I would like to thank once again all the panel speakers, but also the attendees, because of course, without the attendees, there wouldn't be a Congress. And hopefully we can see you next year, but then in real life.
In real life, yeah. I think we all are hoping so. So as Peter has said, thank you so much for all the assistance. Thank you so much for Ignacy, Sonia, and all the people has collaborated into the organization. To the panelists, okay, for your interesting presentations and all the knowledge and all the passion that you are putting in them. Okay, so it's a pleasure. It's a pleasure to be part of this, and let's keep working on this. So thank you so much. I think next time will be a beer, okay, after the Congress. Now I think we should be doing offline, okay, online, sorry, but thank you so much, and see you soon. Thank you.
Thank you. Bye bye.
Thank you. Bye bye.
Thank you. Goodbye.
Bye bye.